Hey, Mark, can you hear me?
I can, Buzz. Is that you?
Yes, it is.
All right.
Good to see you.
Well,
Should I turn my camera on or leave it off?
turn it on right when you talk, but until then, leave it off. But we're getting ready to roll in about 1 second, so just mute yourself until I call on you in about 15 minutes. Good afternoon, everyone. Welcome to the 2020 Florida Asphalt Digital Conference. I'm Mark Musselman, the president of the Asphalt Contractors Association of Florida, and I'm thrilled to be with y'all today, but obviously disappointed that we're not doing this in person. As many of you know, we planned and really tried hard to do an in-person conference this year in Orlando, but unfortunately, the spread of the virus got to a point where we didn't feel 100% certain we could keep everyone safe at the event. So that being said, we made the tough decision to move to this format, which I'm sure we all have a lot of experience with now. And we've also pared down the conference to the speakers regarding research and from the Florida Department of Transportation. Not to project my work habits onto you all, but I've found that a full day webinar is tough for me to stay completely engaged. So we're going to do this over the next 3 hours. I'm going to give a quick update from the association, and then we'll hear from some of the finest asphalt speakers in the Southeast. I'm going to talk and discuss some things regarding the association and what we've been doing and what we plan to do. And then we're fortunately going to hear from Dr. Buzz Powell from NCAT at Auburn, Stacy Miller, Assistant Secretary at the Florida Department of Transportation, Rich Hewitt, State Construction Pavement Engineer, Howie Moseley, State Bituminous Materials Engineer, and Jamie Greene, State Pavement Research Engineer. So this is going to be a really good panel if you're interested in Florida asphalt, and if you're not, then you're probably at the wrong webinar to begin with. One thing I wanted to note is the overall success of Florida's pavements. Over the past several decades, I've always heard that Florida has the best pavements in the South. Now, I grew up in the asphalt industry, so I heard that from people who know the data. But we've seen data from the trucking industry and other surveys that show that Florida's pavements are consistently rated among the highest in the country. And honestly, if you just drive to some of our fantastic neighboring states, you'll notice that there's a bit of a decline. The Reason Foundation, every 2 years, they do a full study of all of the highway systems across the country, and they give every state a ranking. They do pavement condition. They also do safety and spending and all sorts of other things. But as this is the asphalt conference, we're going to talk about pavement condition. And if you look at the urban interstate pavement condition, Florida ranks number 14th in the country. Now, 14th is not bad. And if you dig into the data, you'll see that it quickly becomes difficult to make some of these comparisons. Florida's urban cities are probably a little bit different than Georgia's or Iowa's or Missouri's, but 14 again, nothing to frown at. The rural interstates are even better. We're ranked number 9 in the country, and I think that's top 10. That's really strong for Florida. Rural arterials were number 3. That's very good. And I think that we could all agree that those are some of our strongest parts of our state highway system. But urban, we are the #1 state in the country for urban arterials. And that's those are probably the vast majority are highways that are maintained and constructed by the Florida Department of Transportation. So big hats off to them. And the great thing is if you take these 4 stats and you combine them all, and it gives you a better picture of where Florida is across the entire country. And we are #1. And that's really good for this group, for the contractors in the group, the vendors in the group, and obviously the Florida Department of Transportation. Having the best pavements in the country is a huge accomplishment. And representing the asphalt industry, I have to admit, we can't sit here and take all the credit because as we know, Florida's highways are only paved with 97.3% asphalt. So let's only take 97.3% of the credit on this one. The quality of our pavements, as we know, is good, but what's interesting is it's continuing to get better. I've sat down with the department and we've looked at data for the past several years, and the smoothness data that we're getting continues to get smoother. The densities are getting better. So across the board, Florida's doing better. Now, the association for the past 40-something years has given out statewide pavement awards. And this year, we got more applications than ever before. The application process for these awards is not easy. There's like a 10-page PDF you have to fill out perfectly. You have to do a lot of work and pay a sizable application fee. So to apply for this, you have to be fairly certain that your pavement's going to win. That being said, we did look at the data, and this was by far the most competitive year we've had. And a lot of the pavements that honestly didn't even make the final round of judgment would have won the statewide award in previous years. But every year we give 3 statewide awards, and winning one of these is a huge accomplishment. The first one is for rural resurfacing. This is for state primary highway or rural county highway pavements. You have to have at least 10,000 tons or an equivalent measure. And to be a rural resurfacing project, you have to have 51% of the project needs to have paved shoulders. This year's winner was Preferred Materials. State Road 49 from State Road 55 going north to the Gilchrist County line in Levy County. Congratulations, Preferred Materials. This is a huge accomplishment. Bill Sullivan, Paul Verborny, Greg Lord, Jody Haviland, Randy Larkin, and Jared Cootie. Now, the thing we all know is that Preferred Materials, they're out there building this pavement, but they're not doing it alone. In fact, in a way, they kind of come in and just do the end. The department's doing all the design, all the inspection. And so the Florida Department of Transportation, we feel, also wins this award. And so I'd also like to congratulate Alex Ruiz and Brandon Chatwood. Urban resurfacing is a similar award. In this case, instead of looking at a paved shoulder, you're looking at curb and gutter. We've announced all these finalists in our monthly newsletter. And if you're watching this and saying, Mark, what monthly newsletter? I never get it. Please go to floridaridesonus.org and click on the news section, and you'll be able to register for our monthly newsletter. We put all sorts of things about pavement awards and upcoming events, and occasionally a little bit of Musselman humor. Regardless, the finalists were announced there, and the champion of the Urban Resurfacing Award is Preferred Materials. 2 wins for Preferred Materials is really fantastic, so congratulations to that team. The Urban Resurfacing Award is for their project on State Road 105 from Parker Avenue to Fuel Farm Road in Duval County. Jason Johns, Haymont Seneth, Scott Dampier, Jody Haviland, John Holtenand, and Robert Brinson. And from the department, we want to congratulate Gregory Perry and John Patterson. The AP Bolton Award, this is the big one. This is the overall best pavement in the state of Florida. It's for new construction, reconstruction, or a major overlay. There's a 30,000 ton minimum. This year's AP Bolton Award winner was Preferred Materials. For State Road 25 US 441 from Northwest 167th Boulevard going north through the town of High Springs to the Columbia County line in my home county of Alachua. Obviously, winning this award on its own is a fantastic achievement, but to win all three of the association's statewide awards is really remarkable. In fact, it's never been done in the association's history, so congratulations, Preferred Materials. These names, hopefully I say them right because this is the third time: Bill Sullivan, Paul Vaborny, Greg Lloyd, Jody Haviland, Randy Larkin, and Jared Goody. And then also Alex Ruiz and Kevin Wagner from the Department of Transportation. Major hats off to y'all. This was a great year for Preferred. And I do have to say, it was a great year for a lot of other contractors. And in any other year, I think our second and third place in some of these categories would have still taken home the top prize. We also partner with the Department of Transportation to recognize the smoothest pavements of Florida each year. Smoothness is a really important pavement feature. The smoother a road is, the lower the user costs will be by way of maintenance and fuel consumption, and the longer the pavement will last. So there's great incentive to have a smooth road financially, and obviously it's more enjoyable to drive upon. We have two categories. We have primary roadways and limited access. In general, I think if you looked, the way we measure a pavement smoothness is something called the IRI, the International Roughness Index. The lower the number, the better. So in general, if a pavement's below 45, that's pretty smooth. That's very good. So our runner-up in this category, and their picture is already on the screen of the project, so hopefully some of you out there already know that this is y'all. This was from State Road 223 to State Road 100, or State Road 223 from State Road 100 to State Road 16 with an average IRI of 34. Anderson, Columbia, the powerhouse of North Florida, an IRI of 34 is really remarkable, so well done, Anderson. Our primary roadway winner was State Road 100 from the Union County line to Academic Avenue. 2 lanes, 7.3 miles, an average IRI of 33, so just barely eclipsing Anderson's fantastic performance. Preferred Materials. Well done, Preferred. Limited access, this is our interstates and our turnpikes. The runner-up was the Florida Turnpike in Palm Beach County from milepost 106.1 to 112.212. 4 lanes, 6 miles, an average IRI of 38. The fantastic folks at Ranger Construction. Well done, Ranger. That's a remarkable achievement on Florida's Turnpike, 38. And our limited access winner, I think this is a fairly recognizable picture for probably most of y'all in the audience. It's I-75 at State Road 644. It was 1 mile and 4 lanes with an average IRI of 37. So barely eclipsing Ranger, but it was our dear friends at Ajax Paving. So Anderson, Preferred, Ajax, and Ranger. Building smooth pavements helps the Florida asphalt industry, and that helps me personally. So thank you very much for the great work y'all have done. One more award, and this award is different. It's not given out by the association. normally physically give it out. It's awarded by the Asphalt Pavement Alliance, and it's for perpetual pavement. Perpetual pavements to me are really remarkable feats of engineering from our asphalt engineers. And basically what they've done is they've taken these very difficult materials to control, rocks and binder and perhaps some additives, and arrange them in such a way that they can ensure that the distresses the pavement receives only happen in the top layers. So when you do have a crack, it's easy to mill off and replace, and thus the pavement lasts forever. Asphalt is the only pavement that has this ability to be built for a perpetual life cycle, and it's a huge advantage to us in the industry and then also owners of the pavements. So this award is really tough to win. I will say Florida has won it 10 years in a row. The FDOT has to send a detailed application to the Asphalt Pavement Alliance. The project can't have any structural failures for the last 35 years and no more than 4 inches of overlay. The nominations are evaluated by our dear friends at the National Center for Asphalt Technology. And this year we are happy to say for the 11th year in a row, the Florida Department of Transportation was awarded this award for State Road 9, I-95 in Duval County. Congratulations, FDOT. The department's submitted an application recently for next year, so there's a possible we'll be going for 12 years. The designers at the department deserve a lot of credit for that. I believe there's only one other state with a streak as long as Florida's in receiving the Perpetual Pavement Award. So hats off to y'all there. All these awards, congratulations for winning them. If you did win, they're sitting back there, and soon they will be in a FedEx truck on the way to y'all's office. And so in the case of Preferred, thank you for making my job easy there. One more thing before we move on to Dr. Buzz Powell. The Asphalt Contractors Association of Florida is going to be hiring. We're looking for a technical director. This person can live wherever you want in Florida and will assist the association with all matters technical, working with the Department of Transportation and our dear contractors across the state. I think would be a pretty exciting job to have, and as an engineer you'd have a lot of flexibility to work in a lot of areas related to asphalt. You would also work for me, and not bragging, but I've been called one of the top 3 directors of the Florida Asphalt Contractors Association ever to work for. With that being said, thank you for joining me on this webinar. I really think that the quality and content of the presentations is going to increase throughout the day. And we are going to try to stick pretty much to the schedule. So if we finish early, we may take a little break here and there. Also, this platform does have the ability for y'all to ask questions. If you can't figure that out, you can email them to me. My email's on the screen. And I'll bug the presenters with those questions. And with that being said, I am going to change the presenter to Dr. Powell, and he's going to talk about HYMA and aramid fibers. Dr. Powell, I see you on the screen.
All right. Can you see my introductory slide there, Mark?
I can. And Dr. Powell, you mind if I give your introduction real quick? I guess I should have done this first. You have to forgive me. I haven't hosted it.
Hey, however you want to handle it, Mark.
Just so y'all know, Buzz Powell earned a PhD in civil engineering at Auburn University, War Eagle, with an emphasis in pavements and geomaterials. He worked for 12 years at the Alabama Department of Transportation and 2 years in the private sector before becoming NCAT's first test track manager in 1999. He's now an NCAT Associate Director and Auburn University Research Professor. He was my old professor. And we're very excited to have him here. And with that being said, thank you for indulging me in that, Dr. Powell. And the virtual floor is yours.
Well, thank you for the introduction there, Mark. And before I get started, I'll say that we did play a little football game this past weekend, and you know we're still working on our mail-in points. So I'm confident that when those arrive, we'll be declared the victor of that game. So Mark, we can take some some comfort in that.
Absolutely.
Well, I appreciate the opportunity to visit with a lot of good friends today in Florida, and talk to y'all about our experience with Heimer mixes and with aramid fibers. So that's going to be the focus of my presentation, as Mark said, and I really appreciate the opportunity to share with everybody today. Well, if there may be some people not familiar with NCAT. NCAT is a nonprofit research center located here at Auburn University, and we've been around since the mid-1980s for a very long time. It's hard to believe, but I've been here. This is my 22nd year now. That's very hard for me to believe that, but we do innovative, relevant, and implementable research to provide safe and sustainable asphalt pavements. So it's we do very practical research. We do research for FXWA for a lot of different states and even for private sector clients. And the NCAT pavement test track has been operational since 2000. It's the biggest project that we do at NCAT, and it's actually the biggest project at Auburn University last time I checked. So we're proud of that as well. So this type of research is called accelerated pavement testing. And there are different ways to do accelerated testing. We use these heavy triple trailer trains that you see in this picture. Every axle on that truck is loaded up to, but not beyond, the federal legal bridge limit. So we don't have any bridge spans to collapse. We want as much equivalent single axle loading, realistic load level damage as we can get. So everything but the steer axles on that truck are loaded up to, but not beyond the federal limit. That gives us a gross weight that's about twice the legal limit, but we don't care about that. So that's a picture of the east curve of the track, where Florida has some test sections, and that are beyond the scope of the discussion today, but that research is ongoing in this cycle. We run 5 of these trucks at a time. So we run 2 shifts of drivers. Each driver, their goal is to run 200 laps. So each one of those 5 trucks does 400 laps a day, and then we do that 5 days a week here. So this is our type of accelerated pavement testing. It's a high-speed load event because it's an interstate simulation, and we use legal loads. Now, we do research here. Florida DOT has been one of our sponsors going all the way back to the first research cycle here. And the research that we do at our track is essentially the high-speed, full-scale legal load companion testing that is in many cases done with the HVS test program that is run in Gainesville. So if you're curious about how it all fits together, we do our research in collaboration with the accelerated testing of a different type that's the slower speed variety, typically a higher load variety, but the results are often compared to each other in order to provide the most value for the Florida Department of Transportation. So Florida's actually been, as I said, was one of our inaugural research partners here. So Florida's been very involved in the NCAT pavement test track, going all the way back to the planning stages in the late 1990s. So we very much appreciate and respect the relationship that we have with FDOT, and especially the practical aspect of the research program and the technical support that we are often blessed to be able to provide to our friends at FDOT. There are a lot of states on this slide, a lot of northern states. So we started out when Florida helped to launch the track in the late 1990s. We essentially were the SEC test track, for lack of a better way to describe it. But now you see a lot of states that are outside of the SEC, outside the Southeast, and even a lot of northern states. And many of the northern states have joined in partnership with Florida because of a formal partnership that we have with Minnesota DOT in order to tap into the Minnesota Road Research Project. So a lot of the test sections that we build here at this facility, we build the same test sections now in offset years up in Minnesota. So we have the hot weather fatigue cracking test sections typically down here, and then we've got the cold climate thermal cracking, aggressive thermal cracking test sections that we also build in Minnesota. And we're very proud of the relationship that we have with the Minnesota part of our research family, and all these findings really just create more value for Florida DOT and help us to expand the scope of our program, and also to keep our costs down on a per state basis. So we're very proud of that. Now, our experience with HIMA binder goes all the way back to the 2009 research cycles. That was a long time ago, and I think we had we ran the very first HIMA binder pavement that, as far as I know, was done in this part of the world. And we did it really as part of what we call the original group experiment, the GE study. Well, in this study, state DOTs, and Florida is in this group, funded research to study the effect of warm mix asphalt, warm mix asphalt versus hot mix asphalt, virgin mixes versus high rep content mixes using different types of warm mix additives, and including PFC surfaces. What's the structural contribution of PFC surfaces? So this is a very practical research project, and we built these pavements at 7 inches because we knew that we would be able to fail them within a reasonable period in time. Now, what you see outside the box on this slide, those were 4 test sections that were funded by private sector clients. They paid the same fees that our state agency funding partners paid. And the one that I really want to focus on is the one that's labeled Craton Modified Mix. That pavement was actually built 5 3/4 inches thick. So you expect to see it bending in a completely different way because it's being exposed to the same loadings, but it's significantly thinner. And so you would expect to have a different fatigue life in that buildup. Now we did a lot of basic material testing and advanced modeling to support this research, and Craton was confident that, hey, we're going to see good performance when we put this mix, run it through a plant, and we put this mix on the track. But it was 1 1/4 inches thinner than the test sections that were sponsored by state DOTs. So this is about as complicated as the data is going to get that I'm going to show you guys. This is I think is a really practical presentation for the benefit of agency personnel as well as contractor personnel. But this is a plot that shows how many bending cycles you can expose a beam to before it cracks, before you bottom up crack it, like you would bottom up crack the lowest layer in a non-perpetual asphalt pavement. Mark, he talked in his perpetual pavement award as a perpetual pavement being something that never fails from the bottom. It always has surface distresses that you can just mill and inlay, and it lasts forever. These are definitely not perpetual sections. These are thin enough that they are going to crack, that they did crack on the bottom, and then we can look at how the life compared with all the different treatments in that study, and then evaluate them in a standalone basis, and then also compare them to each other. So this is a plot that essentially shows how many cycles to failure, how many times you can bend a sample in the laboratory before it fails. So the y-axis is more bending as you go up, and then the x-axis on this is cycles to failure. So when you go from left to right, you have more bending with less cracking, more cycles to failure essentially. And what I want to point out here is the purple data. That is the HIMA binder mix, and if you look at the strain magnitude that we measured at the bottom of that thinner test section, it was about 8 million cycles to failure. And if you compare that to the control mix, to the control section, identical mix, but 7 inches thick, and with conventional SBS modified binder, it only went, I think, 300,000 cycles to failure. So in the lab testing portion of this study, we knew we really had a winner here in this material, and it was going to be extremely crack resistant as we installed it on the track. So now the height of these bars is cycles to failure, forecast cycles to failure, which ended up matching up really well with what we observed on the track in that 2009 and then subsequently the 2012 research cycles. So as you go from the control mix on the far left to the HYMA mix, the second from the right, that the height of those bars is the difference in fatigue cracking performance. So tremendous improvement in fatigue cracking performance to the point where we were never able to fail the HYMA section on the track, even though it was 5 3/4 inches thick. We really think that it had the potential to be a perpetual pavement had we left it on the track and studied it with enough easels, enough research cycles to prove that. As it was on the track for 2 research cycles, and it never failed and never had any kind of substantial distresses on it. So outstanding performance with HYMA binder. And what that translates to, very conservatively viewed the data, since we didn't fail the HYMA test section, it has a layer coefficient that is at least 43% higher than the control section in this study than conventional hot mix asphalt. And what that equates to, if you look at the differences in thicknesses, is 1 inch of HYMA mix is approximately equal to about 1 3/8 inches of conventional hot mix asphalt, you know, with conventional, say, 7622 polymer modified binder as opposed to the highly polymer modified binder. So you get a huge benefit when you use these at the time, which was a very innovative material. So when we saw that performance at 5 3/4 inches, we had subsequently had another section on the track. On the far left there, you see it was 10 inches of hot mix asphalt on top of a weak foundation. It was a foundation that was a simulation for Oklahoma. This was an Oklahoma test section, and at 10 inches, that's not a perpetual pavement because the subgrade was so weak. It was a highly plastic, very high PI type of material, and it actually started failing after about 8.5 million easels. We did a conventional rehabilitation of that, and for the next research cycle, which was 3 inches of dense graded under 2 inches of SMA with a paving fabric in between them, and it failed again about 1/3 of the way through the research cycle. So we had this HYMA study result, these HYMA study results that looked outstanding at 5 3/4 inches, looked perpetual at 5 3/4 inches. So we thought, hey, let's try a mill and inlay of that buildup with a little tweak to take the surface mix and build it as a rich bottom. So we've got a surface mix sandwich with 2% air voids at the bottom, and then a base binder mix in the middle. We did a 5 3/4 inch inlay, and essentially we floated a perpetual pavement on top of a completely failed pavement that had not previously survived with a 5-inch mill and inlay with an SMA surface mix. So that study was so successful that Oklahoma actually implemented this, and now it's been done numerous times on their network with great success. So because of the pool fund research cooperative nature of our experiment, state started to pay attention when we saw that perpetual performance, and then we saw that we salvaged a failed pavement with it. Alabama DOT had a U.S. route down in Troy, Alabama, where 2 different SMA mixes had failed in rutting because it's very slow speed, really high truck traffic, stop and start truck traffic. You can see that the deformation in this mix was actually in the HMA, or was in the SMA binder layer. It was not in the surface layer. The surface layer, it rutted in as a reflection of what was happening in the underlying SMA layer. So those are 2 different SMAs, a larger stone under a smaller stone. I think it was a 9.5 in mass over a 12.5 in mass. So Alabama came to us and said, hey, do you think that this HYMA binder would work here? And the 2 big advantages that you get from HYMA binder mixes are improved cracking performance and improved rutting performance because of the elastic recovery potential that the mix has. So we did a forensic study out at the project, looked at all their data, and said, you know what, we think this could work really well. Turned out to be an interesting project for Alabama. They did it. They had to do it as a night job because of the extreme traffic on this route. This was the first Hyma binder project in Alabama. It was about way back in 2012. So there was a lot of apprehension in the bidding process, and that's one of the fun things about NCAT is we get to provide technical support to state agencies as well as contractors. And so Alabama DOT, they told their potential bidders on this job, hey, contact NCAT. They've got experience with this material. They can, provide you with any cautions or reassurances that you need to get your bid together. They built this as a night job. It was very uneventful. They had no problems with production or placement or compaction. Met all their quality targets. And then I just recently wrote an article about this project with Frank Bell, and if you can go to the NCAT website, ncat.us, and download it. It's in our most recent newsletter, and this is one of the graphics from that article. So it shows from AlDOT's pavement management system, the dots are the average rut depth numbers on this project over time, and then the shaded area is plus or minus 1 standard deviation. So you can see there's big rutting that occurred that was previously there back in 2006, and it was rehabbed. It was resurfaced, I think, in 2009, and then again, I think, in 2011. So I'm gonna try to pull my pointer up here and provide you with a little bit of guidance. I think right in here they milled it and inlaid it again with another SMA since this SMA had rutted, and that break corresponds to the mill and inlay still had major rutting. So we came in 2013 or late 2012, early 2013, and we replaced it with dense graded Hyma binder. So we came in and replaced a polymer SMA mix, 7622 mix, with a dense graded Hyma binder mix. And we actually focused the Hyma in the binder layer and put a conventional 76 surface mix, kind of a lower cost roof on the house, since the higher shear in the mix was in the binder layer. And as you can see, they're extremely pleased with the performance that they've gotten from this Hyma mix that we put on US 231 in Troy on this project. Performance has been outstanding. If you want to learn more about that, you can look that up at ncat.us in our newsletter. You can download that. So fast forward to the Greene group experiment on the track. It was also in 2012. We had 4 test sections in this experiment: a control section that was just a relatively low wrap content mixes. Then we had a ground tire rubber focused variant, a RAS focused variant, and a high wrap focused variant of the standard wrap control mix. So the idea was, can we use high percentages of reclaimed and recycled materials, and consisting of wrap and RAS and ground tire recycled tire rubber, and reduce construction costs and extend the life of the pavement. And the interesting thing about this is the high wrap focus section. I'm mentioning this because in the base layer, it had a 35% wrap dense graded mix design with Hyma binder. So up until this time, everything that we'd done with Hyma had been with virgin mixes. Well, here we stepped out and said, okay, let's do something. We would allow in Alabama 35% wrap in a base and binder layer, so let's do that here. But the problem with this is we had 35% wrap in the base with Hyma, 50% wrap in the intermediate layer, and then we had an SMA surface. So this 50% wrap intermediate layer was a relatively stiff layer because it had so much wrap in it, and we didn't use a softer binder or a recycling agent or anything. It was straight 6722 neat asphalt, and so there wasn't a lot of rock interlock between the base layer and the binder layer in that buildup. So the first time we built it, this thing debonded and failed relatively quickly. After just about 2 million easels, failed very rapidly. So we rebuilt. The states that funded this experiment came together and said, well, we want you to rebuild this section, do a forensic study, and try to fix the deficiencies, the things that contributed to this failure. So we did that. We rebuilt it, and it went from being the worst performer to the best performer. So again, the Hyma binder with 35% wrap really paid off for us in the track research program, because it allowed us to use a lot of wrap in that section, and we got the best performance in the entire study. It didn't start cracking till after 4 million easels, and it performed extremely well for the entire rest of that research cycle. Also in 2012, and then again in 2015 and 2016, we've used Hyma binder in our pavement preservation research. I'm not going to go into a lot of detail on this, other than to say that our hot mix component of our preservation study is a 3/4 inch thick, 4.75 in mass dense graded mix. And we've done the same mix in Alabama, low traffic and high traffic, that we have done up in Minnesota. This is a shot of a Hyma binder, 4.75 in mass, 3/4 inch thick thin lay on US 169 up in Minnesota, in a very aggressive thermal environment where it gets down to minus 40 degrees Fahrenheit. That's hard to believe for all of y'all in Florida. It's hard for us to believe that in Alabama, but it does get that cold up there. And you can see they have a very aggressive thermal cracking, and you can see how ugly it is here on the shoulder, and it's pretty tight and controlled in the Hyma binder thin lay that you see out in the main line. So Hyma binder has performed well in all the pavement preservation test sections that we built on and off the track. That brings me to 2015. We did an experiment called the Cracking Group. I believe Florida DOT was one of the sponsors of this study. The objective of this was to run a bunch of plant mix, pull samples, also evaluate mix design samples, and do a consensus cracking test that were selected from the list that you see on this page, and see which cracking tests match the cracking performance that we see on the track. I told you before, we did 7-inch thick sections. We got more aggressive with this study. We said, let's do 6 inches. So we've got a lot of deflection that's going on, a lot of bending, but we don't want any cracking in the base layer or the binder layer. We want to isolate our distresses to the surface layer. So we did our base and our binder layers out of highly polymer modified binder. So just as an experimental control, the experiment design team chose to use Hyma binder because of the positive experiences that we had with it in the past on the track. So we built actually 8 test sections on the track that were built with Hyma binder, and that was a different type of a construction activity for us, because usually we're building 1 200-foot test section, and we do that in sublot lifts, and we work our way through it pretty rapidly. This experiment was different because we ran all the base layers and all the binder layers with the highly polymer modified binder, so it took a number of days for us to work through that. That was really the first time that we kind of crashed into a shelf life issue with Hyma binder. That is one of the things you need to be cautious about with it. At least in my experience with it, potentially there've been some improvements now, but from the time it's blended, you've got about 5 days to run it, and then the shear softening chemistry that enables it to mix and compact like 7622. That chemistry collapses and it becomes really stiff, because it does have typically about 3 times the SBS polymer modification. And since we were building a bunch of sections, it was more like a regular road. And when you throw weekends in there and then rain delays, we actually had some binder that we had some difficulty getting out of our storage tank, and that was more like a contractor could experience on a real project. So that is one of the things you have to be cautious about when you're engaging in work with this material. But we really believe in it and the performance of it, and we've used it again numerous times on the track. That brings us up to 2018, and the state of South Carolina is funding research to do full depth rapid rebuilds, and in their test section we went 8 inches, actually a little over 8 inches, I think, in a single pass. And in their section, it was placed with conventional binder. But to practice for that, we did 2 other test sections that we built with Hyma binder. So the reason why I'm mentioning this, we did 8 inches in a single pass with Hyma binder, and we had no trouble getting compaction and production handling, placement, compaction. And we did cores so that we could look at how density varied over depth, and density was great from the top to the bottom. I think in the other 2 sections that we put thin lay surfaces on, those were a little over 7 inches. so they were not quite as deep as the one section that we did for South Carolina. But South Carolina's idea with this type of research is, can we take an interstate that's completely failed and do a full depth rapid rebuild and do it in 1,000 and 2,000 foot pieces without having a big drop off and having to do stage construction, so we can open it to full traffic the next morning. And so we've done that now with diamond grinding for smoothness, and then with am I doing okay with time, Mark?
Yeah, you got 15 minutes.
Okay, I just got muted, and I just wanted to make sure you weren't putting the hook around my neck.
It was the administrator of the go-to webinar. He made a mistake,
Okay.
so I'll make sure it never happens again with him.
No worries, man. No worries. I just want to make sure I'm good with you. So these test sections have gauges in them, so we can measure the bending that occurs, and we have a lot of confidence in the full depth rapid rebuilds with conventional binder, and then also with Heima binder and just with the thin lay surfaces. So that's something that was not funded by FDOT, but that because of the partnership on the track, FDOT gets the benefit from that research, which is the great synergy. I'm an old DOT guy, as you heard Mark say in my bio, so I really like that. So I'm gonna summarize the takeaways for Heima binder, and then I'm gonna change gears and talk about aramid fibers. So on the advantages side, we've got verified performance. We actually been able to calculate a higher layer coefficient and improve structural performance. That's outstanding. You get better rutting performance and you get better cracking performance, and we have that very well documented now. You get longer life, thinner structures, and or faster builds. So there are a lot of advantages to being able to get the structural performance from 1 inch that would take 1 3/8 inches with other mix. And then during production and construction placement compaction, it behaves similar to conventional polymer modified binder, and that's as long as you respect the shelf life and you respect the storage temperature, and you don't drag your feet during compaction, because when this stuff cools down and squats, you're not going to get any more density on it. But it's no different compacting than conventional 7622 up to that point. In the disadvantages side, you do have the limited time to use after formulation. That is not delivery. And again, maybe you need to talk to your supplier. Maybe there have been some improvements in the chemistry, but the last time I used Heima binder, I had 5 days. I essentially was assured that I had 5 days of low viscosity usage from the time it was formulated. So if you think you're saving time by not ordering the load, you need to make sure you know when that load was formulated, was blended at the terminal, because they may just have had it in a storage tank and the clock is ticking on the shear softening package that allows it to be as workable as a conventional 7622. If you're plant personnel, this is really important, because if you tell your plant people, well, hey, this stuff's got 3 times the polymer in it, but it's not supposed to be any harder to work with than 7622, they're going to be tempted to crank up the heat in the storage tank and or crank up the heat in the mix. And when you put more heat on this binder, unless there have been some changes in the chemical packages, it shortens that 5-day window. So you might think you're doing a good thing by storing and pumping at a higher temperature, but you're going to collapse the chemistry faster when you do that. So don't put the heat on it. Resist the urge to put the heat on it. And as I mentioned in that 2012 Greene Group experiment, another caution is you need to make sure you got good tack, because this is a tough mix. You can have the potential for less interlock of the aggregates for the layer that you're compacting and you're putting down in the layer that you're compacting on top of. So you can have essentially a cleaner, more defined layer interface. And when you have that, you need to make sure you got good tack. So when we did that forensic study, we found that we needed twice the specification, kind of mid-specification target range, because we built a textbook perfect test section, and we needed twice the tack in order to optimize the bond strength. And then when we did that, we prevented a recurrence of the failure, and it went, as I said, from the worst performer to the best performer. So I'm gonna change gears now and talk about aramid fiber, and we've used aramid fiber in several different ways on the track, starting with an effort that Alabama undertook to make their OGFCs tougher. We've looked at treating stored mix with aramid fibers. We've run maintenance mix with and without aramid fibers. We did a field project in Georgia comparing a neat asphalt aramid fiber modified to an SBS polymer 7622 modified, and then now we're using aramid fibers this fall in phase 1 studies for the in preparation for the 2021 track. So I'm going to talk just very briefly with the time that I have left about these different uses. In 2012, we didn't see a big improvement in E9B that you see here in the Cantabro loss numbers, but when we produced and placed this mix, in the 22 years I've been here, this is the toughest mix that we've ever worked with to this day. So this OGFC with a good healthy binder content in a thick film coating on the aggregate with the aramid fibers, that was a tough mix, and that kind of led me to be interested in doing other work with it for maintenance purposes. So based on what we saw there, we said, well, let's pull some dense graded mix out of storage in buckets and use this little trailer mixture that we had and see if we can add fibers to it after the fact and see what kind of numbers we get. Well, we tried to do that. I think we had some dispersion issues and we were not able to see the benefit of the fibers in the laboratory. When we ran maintenance mix on the track with it, it's really easy to experiment with this if it's something that you might be interested in if you're a contractor, because you can just put somebody on the belt, put paint marks on the belt and throw a bag up there so that you get the necessary 1 pound per ton. You got to make sure you have a plant that's going to give you good dispersion. We're blessed. We have an Aztec double barrel plant here that we've been using going all the way back to 2003. So for the last 17 years on the track, and the times that we've used the fiber, we have gotten good dispersion with our Aztec double barrel plant. But you need to make sure that just throwing it on the belt, you do get good dispersion. Now there are automated feed systems that do a really good job of ensuring that. This is what our maintenance patching looked like. And if you look at this, we had conventional 76 on the near end of that wheel path patch, and then fiber modified on the far end. When I put this patch in, and we do this a lot on the track, so keep it in mind as you hear people talk about things that we've learned here. This patch was higher, the distresses were higher severity on the far end. This wheel path is, as you can see these transverse cracks over here, this was a pavement that had completely failed in fatigue in this outside wheel path, and the higher severity level fatigue cracking was on the far end. So that's where we put the fiber. So this is conventional mix, and then the far end down here is fiber reinforced mix. And this is after the cracking started to reflect. So we had really eventually much higher level severity reflection cracking in the conventional mix than we had in the fiber mix. Again, not a statistically valid study, just really anecdotal experiences with maintenance patching that we did, but this was encouraging to me because this was a pavement that had failed previously in fatigue. From there, we went to a field project that we did. This was an off-track small project that we did using our automated distress equipment. And in this project, some conventional polymer modified mix was compared to neat asphalt fiber modified mix. And the bottom line to this is we saw no statistically significant difference between the polymer mix and the neat asphalt fiber modified mix in rutting or cracking. So there were not statistically significant differences. And again, it was just a project where we went out with our distress collection equipment and documented this. This project was actually for the Florida fibers. So again, the aramid fiber takeaways in terms of advantages and disadvantages. It's really easy to stop and start this when you do have a plant that's going to give you good dispersion, and that would make it appealing to me if I was a city engineer or a county engineer. Maybe this is something that if it works, you use it in intersections, or if it can be proven in the lab to influence balanced mix design results, maybe you can use it to kind of tweak your production B&D numbers if the agency is requiring those. At least it has the potential for that if the data proves out. Now they have improved systems for adding this material at the asphalt plant, so it can give you really good dispersion with the right equipment, I think, regardless of the plant type that you have. And now there are some competitive options to choose from in the marketplace. You know, I came from Alabama DOT, and I understand the desire that agencies have to not use proprietary technologies. Well, there's some competition out there now that may address those concerns if the agency had those concerns. Disadvantages: dispersion is critical for performance improvement. If you look at the bag of fibers or the larger bales or whatever of fibers, what you see is not kind of the meat of the product. The actual aramid fibers make up a relatively small percentage of the product that you see. So you got to get that dispersed so that you can fully actuate it, I guess, for lack of a better word. Kind of think of it like if you're doing some maintenance work at your house, building fence or something, and you're using sacks of fiber reinforced concrete, fibercrete. You know, when that stuff's all clumped together, it's not going in areas where it's clumped. You're not going to get good performance in areas where there are no fibers, and that's going to happen because it's all clumped together. So you got to have good dispersion with this product. Likewise, this is a big thing. It is difficult to prove the benefit that you get from aramid fibers in the laboratory, and I think the reason for that is because it is a really strong fiber reinforcement, and you have to mobilize the fibers in order to prove the benefit. So that is a concern that some of us have, that maybe our BMD tests that are the really simplified tests that are highly implementable, maybe they don't capture the benefit of that. And also the laboratory dispersion is harder to do in the laboratory. You really got to know what you're doing in order to get this stuff dispersed, and then have a good simulation event in order to see the benefit. We have some preliminary data that is promising at NCAT now, but we do need to do some independent verification, and that brings me to my final comments in this presentation, where I want to talk about the 2021 additive group experiment, the additive group study that we're going to be building next summer. In this study, we're going to be using recycled tire rubber, recycled plastics, and fibers, and add those materials to control mix test sections, and then we can measure the layer coefficient from these products by comparing them back to the control section. This is desperately needed by state agencies, and in addition to being able to measure layer coefficients, we want to validate a framework that the agency can use without building track test sections to validate future products. So we're right now going through what we're calling phase 1 studies at NCAT, the phase 1 studies are funded by vendors. We're going to share those results with states like Florida that are participating in this experiment. The states that are providing the funds are going to vote on what they want to include from all the vendor products, and we're going to have 7 test sections on the track, 6 treatment sections. So there'll be 6 opportunities to evaluate additives, measure layer coefficients, to calibrate the ME models if you're an ME state, and then deliver that validated framework for future evaluations, which is really important for a product like the aramid fibers that are really hard. It's hard to capture the benefit in the lab. So we intend to build an evaluation program for that. I also want to add that it kind of piggybacks onto the Heima binder discussion. BASF has a product they call B2 Last that they are developing to piggyback onto conventional polymer modification to take essentially a 7622 and possibly create Heima type performance from it. But their goal is to do that without the shelf life and still have the reasonable viscosity to work with. And BASF has indicated that they plan to build an AG plus test section to compare to these other test sections that are going to be funded by state agencies. So these sections are going to be relatively thin. This could be really important for seeing the benefit from the aramid fibers, because we think relatively high strains in order to measure those benefits. 5-inch pavements should fail about 1/4 of the way through our research cycles. So any additive that outlasts the control section, any additive treated test section, that means higher layer coefficient. That means better performing ME model. So those are the products of the study. We're also going to build cold temperature test sections in Minnesota in the following summer 2022. We offset a year so we can get fully mobilized for that. And in Minnesota, we're going to have 6-inch pavements up there where it's just a mill and inlay for 200 feet. It's going to be reflective cracking focused for 200 feet. And then for 100 feet, we're going to be looking for sympathy cracking. Sympathy cracking up there is when they just mill and inlay the main line, the lane, the paved lane, but they leave the shoulders, and they can have these really aggressive thermal cracks on the shoulders that can work their way out into the lane that has been paved relatively quickly. So we're going to look for cracking, measure cracking with a thermal focus in these 3 ways in our Minnesota test section. Minnesota test sections. So we're hosting our end of cycle conference June the 22nd through the 24th of next year. Please note that if you plan to attend, it's open to anybody. We moved it back from April to June based on everything that we were hearing from the CDC and the FDA on when vaccines are going to be available to everybody. We think everybody's going to be able to travel in June. That's as good a guess as we can get right now. Immediately coming out of the conference, we'll be rebuilding the additive group sections and then all the other test sections that we'll have on the new track. So please mark that on your calendar, and we'd love for you to participate. There will be an online option because we, with the 30 states now that are in the NCAT and Minnesota partnership, there's still going to be some states that can't travel, so we're going to support them in the best possible way. Well, hopefully I did okay on time, Mark, and there's my contact information. So I don't know if we have time for questions or if we need to move on, but I appreciate the opportunity to share today.
Oh, no. Thanks, Dr. Powell. That brought me back to being in your class about 9 years ago. I do have we got 2 quick questions, and we got about 1 minute for them. So, okay. And this one's, help me out. At what point does polymer modification become high polymer? Is there a certain threshold?
Well, it depends on how the specifications are written, and whether you've got massacre specifications or not. But the fundamental difference is where you might have 2.5% SBS in a conventional 7622, you might have 7 to 8% SBS in a HIMA binder. So the kind of the magic in the chemistry of it is getting that to not behave like a gooey mess when you're trying to produce and place and compact it, and that's that shear softening chemistry that makes that possible.
Fantastic. And then what was the higher structural coefficients that we found? Can you mention those?
Well, I try to just stick to percentages because different states use different layer coefficients. Like we have found, for example, here we essentially used the body of our track data in our structural sections to extend the ASHO road test and to recalibrate the layer coefficients that really came out of the 1950s ASHO road test for the modern mixes and modern materials. We found that number needs to be 0.54. Alabama has adopted that change. I don't think that Florida has adopted that change, and we respect their decision to go with. I think that they still go with the 0.44. Howie may want to check me on that if I'm incorrect. But if you in Alabama, if you've got a 0.54 for a conventional HMA layer coefficient, the number that you would use for HIMA binder would be 0.77. And so for the benefit of our contractors, an inch is about 1 3/8 inches. So it's better to think of thickness equivalency. That's an easier way to understand it.
That is. Well, thank you very much, Dr. Powell. I really appreciate you taking the time to be with us. You've always been a good friend of the Florida asphalt community, and we look forward to continuing that in the future.
Hey, we appreciate y'all, and thank you for the opportunity, Mark.
All right, well, fantastic. Well, up next, we are delighted to have Stacy Miller from the Department of Transportation. Stacy has worked as for the FDOT since 1991. She joined the agency in District 4 as a professional engineer trainee specializing in PD&E and roadway design. After working as an in-house design engineer for several years, Stacy transitioned to consultant management as a project manager and section leader. From 2002 to 2015, she managed the program management office and was promoted to the District 4 Director of Transportation Development in April 2015. In April 2019, she was promoted to Assistant Secretary of Finance and Administration, job she currently holds. She's a graduate of the University of Florida, Go Gators, and is a registered professional engineer in the state of Florida. Stacy, thank you for very much for joining us, and I believe I'm going to present for you. Stacy, is there any chance you have your presentation? I think you're muted. All right. Stacy, I think you are on mute still.
Thank you. Yes, I was organizationally muted, so sorry about that. I couldn't figure out how to undo that.
Not your fault. We've got the worst GoToWebinar administrator here. I'm going to have a word with him later.
That's all right. I was like, I muted myself and you muted me. I couldn't figure out how to do it. Thank you, Mark. I appreciate that opening, and thank you for inviting me to participate. I caught the back end of the last presentation. Mine will not be that technical at all whatsoever, so I appreciate everyone bearing with me. It will be very high level for the department. Next slide, please. So Florida Department of Transportation has developed a core group of focused areas known as the vital few. And these we are using to fulfill our mission of moving the people and goods throughout the state of Florida. As you can see, I'm going to explain the 4 areas of the vital few. First and foremost, obviously, is improving safety. Safety is the Department of Transportation's top priority, and it is a vital component to our day-to-day operation. One fatality on our transportation system is one too many, and the department is committed to doing everything possible to provide a fatality-free transportation system consistent with Vision Zero. Enhancing mobility. Obviously, the department is dedicated to continuing to enhance our state's transportation system and fitting in current and future needs for our residents and visitors, whether it's through the expansion of our facilities or enhancing our existing roadways or looking towards technology. We are trying to increase multimodal options and are committed to building the future of Florida's transportation system today. Speaking of innovation and using technology, FDOT is consistently using innovation to creatively solve transportation challenges throughout the state, and we've become a leader in the transportation industry across the country. We are using our investments in emerging technologies to improve safety and increase mobility on our roadways. And lastly, we know we can't do any of this without fostering our talent. We can only achieve our mission by recruiting the best and the brightest in transportation professionals in order to provide a safe transportation system. We are working to build the workforce for today, tomorrow, and into the future. Next slide, please. So it's no secret we're all feeling the impacts of the past recent months, particularly when it comes to revenue. At the time that the budget was signed in July, The State Transportation Work Program was a very healthy $9.2 billion. In September, the Revenue Estimating Conference projected that we would see a $1.6 billion shortfall through fiscal year 26. This means we have to reduce our programming to offset the loss of revenue. The largest reduction, unfortunately, is coming in the current year, fiscal year 21, and that's $760.3 million. The department is currently actively reducing our allocations in program areas with the goal of minimizing impacts to existing contractual obligations, it's our outstanding debt, to safety and preservation. To mitigate the magnitude of this $760.3 million impact, the department has to determine the amount of allocation reductions, and in some instances, they're lower than our required statutory obligation. As we're making these decisions, the department is exempting from the reductions planned safety projects, our $14 billion of outstanding contractual obligations, and planned preservation, boy, say that 3 times, such as debt service payments, executed public-private partnerships, and other legal agreements. We're also reducing operating budget and increasing our planned bonding for the next few years to help mitigate the impact. Our goal is to protect our funding for our outstanding obligations. Obviously, we don't want to stop any of our active construction projects, and then preservation, all of our resurfacing, bridge repair, replacement, and maintenance. As you know, the department is primarily funded through gas tax, and there's been a significant impact on those revenues. Without a policy shift at the state and federal level, we are concerned that we will continue to see decreases in fuel consumption, no matter what the situation. The current environment that we find ourselves in is very unique, and we are gradually seeing a rebound. Our hope is that our state, our nation will continue to recover, and that revenues will soon recover as well. We anticipate receiving an updated projection from the revenue estimating conferences this month in December, and we're hopeful, at least if we don't get to see an increase, we're hopeful for a status quo scenario. Next slide, please. So the back one. So the resurfacing program. So as of November 24th, when we scanned for this information, the current 5-year work program has $5.4 billion of resurfacing. That's fiscal years 21 through 25. That $5.4 billion is quite a significant amount. Most of that, 97% of it, is actually flexible pavement. Very little of the department's system is rigid pavement. The amount of resurfacing dollars obviously varies from year to year, as the resurfacing program is needs-based. And it's determined by the actual level needed in each district in both rural and urban facilities, enough to maintain our standard above 80%, which is our statutory obligation. There are currently not quite 11,000 lane miles in total in the 5-year work program, which is approximately 2,200 lane miles per year. On the actual projects that are currently programmed, there's about 6,600, and then we have funds set aside for the final 2 years of the work program, and that equates to about 4,300 lane miles. The resurfacing program itself compromises approximately 24% of our total construction program. That includes the capacity, safety, bridge, and resurfacing program. Next slide. Next slide.
I'm seeing a message that says there's technical.
Sorry. I apologize. We lost connection here for a second.
Oh, that happened.
This is the slide we want.
Oh, there you go. That's the one. Right. Yep. That's where you are. Thank you. No problem. No problem. Hey, we're all working through this all together, right? Last year, my understanding is that Courtney Drummond spoke with you all, and he actually mentioned the MCORS program, and I just wanted to give you a quick update. So the MCORS task forces held their final meeting the week of October 19th. They've completed their reports, and those reports have been submitted to the governor's office and the legislature as of November 12th. The task force's charge was to provide recommendations for how the department could work with local governments and other agencies to carry out the MCORS program as specified in statute. The recommendations address how the needs and feasibility should be evaluated and how corridor development and related activities should move forward. The task forces provided recommendations in 4 key areas. The first is high-level needs in each study area as it's related to the 6 statutory purposes that are outlined. The task forces determined that there were no specific needs for new greenfield corridors or modifications for any existing facilities through the study area based on the information that's already currently available. Project level needs will continue to be evaluated as we move into future phases. The task forces also recommended a set of guiding principles or core values to support decision-making related to each study area. The task forces had robust discussions in key topics, including how to locate and manage lands around interchanges and how to protect conservation lands and habitat. The task forces recommended instructions for project development and beyond, and ensured that those guiding activities for each study area would be maintained. The commitments in each of these will be implemented as we move further. Obviously, that's what in all the cases. The task force recommended and the department committed to a specific action plan for future activities, again, in each study area, consistent with the guiding principles and the instructions. The commitments in the action plans indicate how the DOT will work with local governments and other agencies to carry out the task force's recommendations and augmenting the statutory requirements and the department's procedure. The action plan has 8 key elements: evaluating potential needs, identifying and evaluating alternative corridors, support and consistent review and updating of local and regional plans, assessing economic feasibility and identifying potential funding sources, advancing innovative land acquisition concepts, advancing multi-use opportunities, and continuing with partner and public engagement. And lastly, a commitment to transparency and process improvement. All of these will be moving into the next steps of the process. The department is currently wrapping up the step 1, which was the task forces, and we are moving into step 2, which is the planning and corridor evaluation. We will ultimately move into PD&E design, right-of-way acquisition, and leading to construction. By statute, we are required to begin construction no later than December 31st, 2022, and the corridors are to be open to traffic no later than December 31st, 2030. With that, as I said, it was not going to be as exciting as your prior presentation. So, Mark, I'm not sure if there are any questions from anyone for me. I know I did that kind of quick. Didn't have that many slides.
Well, thank you very much for your time, and I apologize for the brief technical difficulty there.
Quite all right.
We just had a couple questions come in. One is you mentioned the 80% non-deficient threshold. That's obviously the absolute minimum. What's the department's goal? Is there a number greater than 80 that the department shoots for?
Well, that actually has changed over the years. And I will admit in some prior years, we've been in the mid to high 90s in a lot of instances, but it's all very dependent. Obviously, to maintain the roadway condition to that level is very expensive. So by statute, we're required to do 80%. We've always tried to strive for more, but it's a balance between spending those resources to far exceed the statutory obligation. We do feel here in the state of Florida that we have an excellent roadway system. Our pavement condition is amazing compared to some other states that you drive in. We're obviously lucky. We don't have freeze thaw. We have some other benefit being here in the state of Florida. But we strive to obviously exceed the 80%, but we are definitely trying to self-adjust down from the mid-90s.
Well, you missed my presentation where I discussed how Florida was recently ranked the best pavement, best state by pavement condition in the entire country. So we're with you there. And I also did know that we're 97+% asphalt. So I think we can do the math on that one. And then finally, when it comes to MCORs, and I really don't want to get ahead of ourselves, is how will the department make pavement type decisions on those projects?
We are far from making those kinds of decisions at this point. We haven't even determined the location of the facilities. So I think those are steps that'll happen during our normal process during the project development and environmental phase, as well as in design when we'll do the rate of return and life cycle costs and make those same decisions we would make under any scenario while we're starting either a greenfield or making a determination if we're widening and reconstructing the facility.
Fair enough. I'm glad to hear it. Well, Stacy, thank you so much for joining us. We really appreciate it.
My pleasure.
And hope to see you again soon. All right, so next we have Rich Hewitt, but we're going to take our quick one break here and circle back with Rich at 2:30. So I'm going to mute my camera and jump back in about 8 minutes. Before I go, I will just give an attendance. We have 227 people in attendance as well as 6 presenters, so 233. So not bad. Look forward to seeing y'all again in about 6 minutes. Thank you. All right, welcome back, everyone. Up next, we're delighted to have a familiar face to our Florida Asphalt Conference, Rich Hewitt. Rich has worked with the Florida DOT for over 24 years. He began his career in the building construction industry and spent several years as a contractor before returning to college at the University of Florida, where he obtained a Bachelor of Science in Civil Engineering. He is a registered professional engineer in the state of Florida. He started with the Florida Department of Transportation as a professional engineer trainee and served in District 5 as a geotechnical engineer, and then the District Construction Materials engineer, and finally the District Bituminous engineer. Rich currently works for the FDOT State Construction Office as the State Construction Pavement engineer. Rich has been involved in many innovations throughout his career, such as the QC roadway report, IRI smoothness incentive specifications, asphalt e-ticketing, and working with districts on writing specifications for 3D model automated machine guidance projects. A wealth of experience and knowledge on asphalt construction. Rich, we're happy to have you. And I believe you're unmuted and we can see your screen, so take it away.
All right, can you hear me?
I can hear you loud and clear.
All right, great. Thanks for that introduction. And today I've been asked to provide a construction update, and I'll talk a little bit about a couple specification changes. I'll also speak about limited access roadway smoothness. I'll cover the IRI projects, the incentive projects, and also speak about the comparison of the ride number projects and versus the IRI incentive projects. Also talk about our non-limited access or primary road smoothness system that's currently being developed with the Smoothness Committee. And I'll wrap it up with some words on e-ticketing and implementing changes. So as far as the specification changes go, Howie Moseley is going to cover most of them in his presentation, but I just wanted to cover two that are closely related to construction. One of them is in section 327. We're adding a section 3.11, and that's going to allow traffic on a milled surface for up to 3 days before paving is required. That's been submitted for the July 2021 workbook. It's currently going through the internal and industry review process. And basically it's going to allow, upon engineer approval, milled surface to be open for 3 days before it has to be paved, provided there are continuous longitudinal milling striations, no drop off or safety issues, and no drainage issues. If those requirements aren't met, then we'll revert back to the pave the day after the surface has been milled. That's currently in the specs. The specs and also this presentation has a link that shows photos of acceptable and unacceptable striations. There's some photos like this one where it shows them side by side. And then there's also some individual photos to show acceptable milling striations and unacceptable milling striations. And we're looking again for those continuous longitudinal striations, and we don't want these gaps in the striations and create those chevrons and create issues for the traveling public, particularly folks on motorcycles and also on cars as they're going through construction areas with barrier wall right near them. Kind of pulls them side to side. Another spec change in 330 and 334. Raised crosswalks and speed tables are being added to the straight edge testing exceptions in 330-9452. We'll still have the 3/8 inch deficiency requirement for objectionable areas that's in the spec now in case there's some poor paving in those areas. The raised crosswalks and speed tables have also been added to the density testing exceptions in 334-512. As far as the raised crosswalks go, I just wanted to thank ACAF and the ACAF contractors who provided constructability input during the creation of Developmental Standard Plan 520-030, and as well as changes to standard specs 330 and 334. And those folks were Mark Musselman of ACAF, Rick Crocker, Preferred Materials, Felipe Jaramillo of Ajax Paving, Julio Leganoa of Howie Engineering Contractors, Chris Harris of Anderson Columbia, Scott Fowler of Ranger Construction, and Pete Franzak and Joe Meyer of Middlesex Construction. So thanks again for providing that constructability input. I think it's great to have contractor input in the design process. That helps for a lot better designs on our construction projects. All right, as far as the limited access roadway smoothness goes, first I'll talk about the IRI specification projects. And I'll cover a couple years just to give you some perspective. In 2018, limited access, the IRI spec projects, that's the projects with the incentive and disincentive specs on them. We had 4 projects. Net incentive was $71,000. The IRI average was 36, and if you look, and that's the green data. If you look at the black graph, that's the interstate data that was used to create the original spec, and that data was from 2005 to 2010, and the IRI average was 48. So in 2018, those incentive projects were considerably smoother. Here's a breakdown of those projects. They all received incentives. They all even used limestone aggregate. And so just a quick overview of that, 4 projects. In 2018, the lowest project average IRI was 34. The highest project average IRI was 37. All 4 limestone projects received incentives. The average incentive was $14.73 per lane mile, and the total incentive was just over $71,000. 2019, we had 6 incentive projects. The net incentive was almost $84,000. The IRI average was 43, and again, that was better than the interstate data that was used to create the spec, which had an IRI average of 48. Here's a list of those projects. 1 project unfortunately did receive a disincentive, but the other 5 did receive incentives. An overview of that. So we had 6 projects. Lowest project average IRI was 38. The highest project average IRI was 60. 5 out of 6 projects received incentives. All limestone projects received incentives, and the average incentive was $355 per lane mile, and total incentives again was almost $84,000. 2020, we've got data up until about mid-November, and so we'll next year we'll report the full year 2020, but just wanted to kind of give you a heads up what's going on in 2020 for the data that we have so far. There were 7 incentive projects, net incentive of $353,382. The average IRI was 43, and that again, that's better than the IRI average for the interstate data that was originally used to create the spec. There's the projects listed right there, some mostly granite, but there was also some limestone projects. So overall, 7 projects. Lowest average project IRI was 24 inches per mile, and that's actually a new state record. So congratulations to Preferred Materials who paved that project. The highest average project IRI was 55 inches per mile. All 7 projects received incentives. 1 project received the consistency incentive, and the average incentive was $1,050 per lane mile. Total incentives again, $353,382, and that total does not include the project-wide consistency incentive that was paid on the 1 project, so it was even more as a total. So just to give a summary of those almost 3 full years, 16 out of 17 projects received incentives. All limestone projects received incentives. Total net incentives paid was just over $500,000. The smoothest incentive spec is a positive, in my opinion, and I think in a lot of contractors' opinions. Provides incentives for smooth paving, and it's providing us smoother asphalt pavements than we've had before. And we're starting out with very smooth pavements to begin with, so we're moving in a positive direction. So I wanted to look a little bit at the ride number jobs versus the IRI projects. So you just saw the IRI incentive project, so let's take a look at the ride number. Now, since they have the data for them, they can also provide the IRI numbers for those projects. And so here again, here's 2018, the ride number projects, but shown in IRI. You can see that that's compared to that interstate data I showed before that we built the spec on. And it's just, the average is 49, which is just slightly rougher than the interstate data that we built the spec with. And if we just look real quick at the 2018 graph I just showed for the IRI incentive projects, you can see that you had an IRI average of 36. So the incentive, really works, and helps contractors go for paving smoother. 2019, same thing with the ride number jobs without the incentive. The IRI average was 52. And if you look at the graph I showed previously for 2019, those 6 projects, the IRI average was a 43. So much smoother on the incentive projects. And again, for 2020, the ride number projects, there were 17 projects, IRI average of 53. And if we move back to that graph I showed before in 2020 for the IRI incentive projects, we had an IRI average of 43. So to summarize, the difference between the IRI average on the ride number versus the IRI projects in 2018, you had a 49 on the ride number projects and a 36 on the IRI projects, so a 7-point smoother for the incentive projects. 2019, 52 was the average on the ride number projects and 43 was the average on the IRI projects, and so the 9-point smoother on the incentive projects. And in 2020, again, that's January through about mid-November, 53 was the average IRI on the ride number projects, and 43 was the average IRI on the IRI incentive projects, and so a 10-point smoother on the incentive projects. So for the IRI incentive, disincentive spec projects, they've been paved smoother than projects with the ride number spec. Those incentive, disincentive project incentivize contractors to pave smoother, and those incentives are benefiting contractors, FDOT, and the traveling public. So next I'll talk about the non-limited access roadway smoothness system, or the primary road smoothness system, and that's something that the smoothness committee is currently working on. We're writing developmental smoothness specifications, and those are for the non-limited access roads, or also known as the primary roads. That's for design speeds 55 miles an hour and greater. It's the roadways that are currently laser tested, but use the ride number. It's going to be an IRI-based smoothness specification, and we'll have smoothness incentives and disincentives. It's going to be based on past construction acceptance data. And that's the same as the current limited access IRI specs are that we currently have in place. However, we're going to split it into multiple classes. And what that's going to do is account for the level of ease or difficulty in order to pave smoothly. So we have a pretty good range of types of projects on these non-limited access projects. Some are in rural locations, some are in very urban locations. And so by having those multiple classes, that'll appropriately evaluate construction acceptance and also fairly incentivize smoothness. This graph shows the limited access 2005 to 2010 data that was used for the limited access IRI specs, and it also shows the non-limited access IRI data for 2014 to 2019. And you can see that the non-limited access has an IRI average of 46, and so it's 2 points smoother than the limited access data that was used to create the limited access spec. So it's pretty similar data, but actually a little bit smoother. And so we've broken that up into 5 classes. And if you just kind of, let me grab a pointer here, a pen. If you look at this class 2, the second row, that's the exact same numbers that we currently have in place for our limited access roadways for the incentive, full pay, disincentive, and remove replace limits. And so we actually have 3 classes, class 3, class 4, and class 5, that have higher IRI limits. So allow a little bit rougher pavement based on the different situations that are encountered in these types of projects. And there's one class that's a little bit, has a little bit lower IRI limits. However, we did not lower the remove replace limit. We kept that at 95. So it'll be a little bit tougher or a little bit lower IRIs to get full pay or incentives, but these projects show that they're, contractors can pave them smoother. This table shows a breakdown of the lane miles, both by district and by class. So each district is a row and each class is a column. And you can see that Class 5, there's very little pavement that's in the Class 5 range, but some of those very short projects had some very high IRI numbers, so we wanted to set up a class for, for those. But most of the projects are going to be in the Class 1, Class 2, and Class 3 pavement areas. Okay, so the incentives per lane mile by class and by district are in this table, and you can see most of them are positive. We tried, we were trying to go for something revenue neutral, but that just wasn't possible. We also wanted to keep all the districts positive, so we didn't want any district to end up negative. So if you look at the last column, that shows each of the districts, the average incentive per lane mile, and so all the districts are in the positive territory. And then each class, we also wanted to make sure each class was positive. We didn't want to have one particular class being negative. And so this table provides a summary of the districts, the total incentives for the 6-year period, 2014 through 2019, those years inclusive, and then the lane miles and the incentive per lane mile for each of those. And so it's a total of about 656,000, but that's over 6 years, so it's about 110,000 a year would be the total incentive for all the non-limited access roadways that we'd be starting out with, and that's what would occur if everybody paved the same as they have paved in the past. But as we've seen with the limited access smoothness spec, we've seen that contractors have paved things smoother and achieved the bonuses. So for the non-limited access IRI-based smoothness system, we're currently writing the developmental specifications with the smoothness committee, and the next steps will be to look for and then put the developmental spec on some pilot projects throughout the state. And as those are occurring, we'll continue the smoothness committee and industry discussion. And the end goal, just like with the limited access, we want to move to an IRI-based standard specification for all laser tested roads. And we want to eliminate ride number and straight edging of laser tested areas. I just wanted to thank everyone in the Pavement Materials Division of the State Materials Office for collecting and analyzing the IRI and ride number data throughout the years, and more currently as we've developed the IRI specs for limited access, and as we're currently developing IRI specs for the non-limited access roadways. And special thanks to Mateo Carvajal of the State Materials Office for the data analysis tables and graphs provided for the Smoothness Committee and for this presentation. Wouldn't have been able to do it without him. All right, e-ticketing. We implemented contactless ticketing in response to COVID-19. That occurred April 20th of 2020. And about a month or two after that, I had sent out a survey to Mark, and he forwarded it to all his contractors. And over 80% of the ACAF contractors were using e-ticketing at that time, and I imagine that number has probably come up a little bit. Some of the advantages that I know I've spoke about before, and I've also heard from contractors recently, are advanced mix and truckload information, better project tracking, increased oversight. You can view paving progress on multiple projects by phone, tablet, or computer. Fleet management's another advantage, and also just having that electronic data in one location helps a great deal for a lot of the processes in paving, and especially payment. So we pretty much, had very few problems that I heard of. And typically most folks are going to call me when there's problems on the construction side. And, I think that's outstanding considering the immediate statewide implementation that occurred. And so I just wanted to thank the contractors, the e-ticketing vendors, the CEIs, and the FDOT personnel who made statewide asphalt e-ticketing implementation successful. And just wanted to say, let's continue working together to quickly implement changes that benefit asphalt contractors and DOT. Regardless of how challenging or risky that change might appear at first. I know with e-ticketing, there were a lot of concerns on how that was going to occur when we first started talking about it, and then especially when we were talking about implementing it in response to COVID. And, I think both sides, contractors and DOT alike, were reasonable in how we tried to implement it. And I think both sides are also finding a lot of benefits from it. Same goes for the smoothness spec. There were a lot of concerns with that initially on the limited access roads, and a lot of concerns with Southeast Florida and limestone aggregates. And we're seeing a lot of positive projects. I showed you those 3 years of data for the limited access, and all the limestone projects got incentives. So let's continue that philosophy of working together to try to make systems better for the contractors and DOT alike. And with that, I'll open it up to any questions.
All right, thank you, Rich. We did have a few questions come in. First one is interesting, and I'm surprised me and you haven't discussed it prior. Okay, so we're looking at the 17 projects, 17 incentive projects, 16 of them received an incentive. How many were done by paving contractors paving their own base or on a surface that they were charged with milling? Is that something the department's looked at?
Not particularly, no.
I'd be interested to see that. It's a small data set. Maybe I could go through and do a little homework and figure that one out.
Okay.
Has the department made any progress in transferring responsibility of smoothness acceptance over to contractors?
We really haven't pursued that. My thoughts on that were, if that's something that industry wants to move towards, we could look at it. I'm not necessarily, looking to move in that direction. But if that's something industry wants, we could certainly look at it. Currently, the ride number projects, they're all ridden for construction acceptance by folks at our state materials office. And so the, acceptance for the IRI projects, that would be no different, in my opinion, to have them ride those. It's the same work effort. Now, if contractors wanted to hire companies to maybe look at, last lift of structure or several lifts as they're paving structure, and do comparison runs, that's their own prerogative. But we're not necessarily looking to hand that over. But that's certainly something we could, discuss with industry if that's what you're interested in.
Interesting. No, I don't. I think we, in general, don't love the idea of duplicating efforts.
Yeah, it's I would say it's a pretty specialized skill set. The folks who drive those laser vans and know how to operate the equipment and do the analysis, and the equipment is not cheap, and so I don't know that most folks would want to go out and either buy their own or do a lot of hire a lot of consultants to do all the work for them. So
fair enough. And then what, so if we, correct me if I looked at your presentation incorrectly, but it looked like the smoothness data on pavements paved on limited access has gotten smoother during the time period that we've had the incentive on the limited access projects. What would you attribute that to? So you had, did I say that right?
Yeah.
Okay.
And I think, overall, we did see some of the limited access sliding back just a little bit, but overall, I think the limited access and the non-limited access, as contractors are paving these IRI incentive projects, the crew and they sort of change some processes or maybe pay a little bit more attention to smoothness. I think some of that is carried over into other jobs. You're not going to forget what you did on the last job. If you're starting to, if you get a few of these jobs and you're starting to, use more practices that are, leading to smoother pavements, you're going to do that probably on additional jobs. And so I think some of that's carryover, into the non-limited access roadways. But you know, and also just you know, we've got a lot of good contractors paving roadways out there, and I don't know, you know, if it's the incentive specs carrying over or just our contractors are getting smoother just on their own.
I'll accept the answer of job well done by the asphalt contractors.
Absolutely.
And then
yeah.
I want to say, and I've alluded to this before, how great I think the smoothness incentive specs are, because I think they're good for the taxpayer in that we're getting a smoother pavement that's going to cause the traveling public to spend less money on maintenance and fuel. It's good for the department because the department gets roads that will last longer, and it's good for the contractor because they get a payout in the form of cold hard cash. So I commend you for your work on this. It's a win-win-win. All right. Well, Rich, thank you so much. We're thrilled we were able to get your wisdom this year after all, and I'm sure we'll be taking you up on it again in future years for a long time coming.
Yeah, well, thanks for those kind words, Mark. And I just wanted to say that, you know, the Smoothness Committee, it's a pretty big group of contractors and DOT folks from the districts and from the State Materials Office, including myself, and you as well. And it's been a group effort to write specs and to do all the data analysis and to try to come up with, you know, systems that are fair and appropriate. And it wasn't easy. And we're still in it on the non-limited access, getting that system you know, created and written into the specs, developmental specs. And so, but I appreciate everybody's efforts on the contractor side and the State Materials Office side, folks like Jamie Greene and Charles Holscher and other folks up there that have put such a great amount of effort into it.
As do I. Well, thank you, Rich. Up next, we have Mr. Howie Moseley. Howie received a bachelor's and master's degree from the University of Florida, both in civil engineering. He's a registered professional engineer in the state of Florida, and he currently works for the department as the state bituminous materials engineer, and previously worked in District 2 as the district bituminous engineer and district materials engineer. So Howie, thanks for joining us, and floor is yours.
Okay, well, thanks, Mark. Hopefully everybody can hear me and see my screen. I'm going to go ahead and turn my camera off for bandwidth purposes, and we'll go ahead and get started. Okay, so you guys have seen my presentation for the last several years. It'll be more the same. Unlike Rich, I don't provide an outline. This presentation's too scattered to even attempt to do that. So, but I do want to provide my contact information. If anybody doesn't have that, there it is. And I'll give Mark a copy of this presentation so he can distribute it after the fact in case you need that, or any of the other slides I'm going to show with all the statistics. Oh, come on, there we go. So I should have done this as a pop quiz because this is the third time you're seeing this information. The state highway system is consisted of nearly 45,000 lane miles, of which 19% is interstate, 76% is the arterials, and then 5% of our system is the turnpike lane miles. And everybody knows these numbers by now. 97.3% of the pavement is asphalt, and 2.7% of the pavement on our system is concrete. Data you haven't seen yet today, just over half of our asphalt surfaces are dense graded, 50.4%. That is by lane mile, and 49.6% of the asphalt surfaces on the department system are open graded. I think that statistic kind of catches people off guard at first, but it is a 50-50 split between the two friction course types, dense and open graded, in the state. Asphalt producers in Florida, we've got 97 asphalt plants in state that are approved for DOT work, and 2 out of state. 38 in-state asphalt contractors approved for work, 2 out of state. 15 approved binder terminals in the state and another 10 out of state, and then approved asphalt emulsion terminals. We've got 5 in state, and then 8 more that are out of state supplying emulsion for Florida. There's a map of the asphalt contractors splattered across Florida, and you can see the 2 out of state ones where the plants are located. The approved binder terminals for Florida, there they are. And then the emulsion terminals, again, we've got one way up there in Pennsylvania, and that's why we got to show the bigger map. But you can see where the emulsion terminals are that supply emulsion products to Florida. Asphalt mixed tonnages, and again, these stats are going to be for the fiscal year. So the stats I'm showing are going to be from July 1st, 2019 to June 30th, 2020. That's just the way we've always done it, and we're not going to change now, even with COVID. So you can see we did almost 4.5 million total tons of asphalt this past fiscal year. You can see the breakdown by mix type. And like I showed earlier, you can see the FC5 is almost as much as the combined dense graded friction courses, just a little less, 500,000 tons of FC5 and just a little bit more of FC12.5 and FC9.5, even though they're thicker. You can see there was a little over 1 million tons of friction course total placed, and then the rest was the structural and base courses, of which the predominant choice has been the SP12.5 millimeter, and it's like that every year. Asphalt tonnage by district, you can see District 5 had the most tonnage placed this year, followed by the Turnpike, and then District 2 is in third. But for the most part, a good smattering across the state. There you can see the different percentages for each district. Asphalt tonnage by producer, we'll keep with the theme of PMI winning everything. They had the most tonnage by any producer in the state this past year. This chart shows all the breakdown for contractors that produced over 100,000 tons of asphalt, but we don't want to not recognize the smaller contractors that are also important to the department. You can see those guys that produced less than 100,000 tons and where they were. So again, we need every asphalt contractor out there. You guys do a great job, and you can just see how much you produced. Mixed tonnage by traffic level. And again, this is the actual traffic level of the mixed design that was placed. Clearly, we have more than 1% of our system being traffic level A and traffic level B roadways, but most contractors take advantage of the ability to substitute up one mixed design level on traffic level. And you can see over half the mix produced was traffic level C, and then traffic level D being 37%, and 7% was E. So again, and that, since we've been allowing the substitutions one traffic level up, the breakdown is usually something like that. This is a new stat. Somebody asked me a couple weeks ago, well, what's the breakdown of friction course aggregate types between granite and then the local Florida aggregates? And I didn't know. So, but Curtis Curl, who works for me, he can mine anything out of MAC, and so he mined this out, no pun intended, last week for me. And you can see this is friction course mixtures only. The percentage of in-state rock, either the Miami limestone or the shell rock, is about 17.5% of the friction course mix placed this past year, and then the other 82.5% was either granite or granitic gneiss. So again, a stat I had not seen before, thought it would be interesting to show. Mixed tonnage by binder type. So we show this every year, and again, as it has been for the past several years, the predominant binder used in the state of Florida is PG76-22. It's really helped improve the performance of our mixture since we introduced it in the early 2000s, and you can see we've really transitioned it from it being kind of a novelty binder to kind of the backbone binder of our system. You can see the percentage of different neat binders depending on the percentage of wrap contractors used over on the left side of this graph. Again, 8222 is no longer in our specs. Just got a couple of projects out there left that still have it on the books, and so we had a little bit of 8222 last year. And then high polymer binder made up 4.5% of the mixed tonnage last year. Again, I'm using it where we really need the top quality binders. You guys heard Buzz talk about the performance improvements it gives. We're using it where the engineering makes sense to use it. Now, if you look at actual binder tonnage, the last slide was mixed tonnage. This is the actual binder tonnage. And again, why is it different? Well, a lot of our mixtures have wrap, and you can see the second most commonly used binder is the binder from wrap at 20% of the binder being used. What's interesting is when you consider the wrap and the mixtures, we actually use more 5822 binder than 5228, even though mixed tonnage wise, there's more mixed tonnage with 52 minus 28 binder. Again, you're getting that advantage of using more wrap binder when you use the lower grade there. And you can see the other percentages are about the same. Wrap usage in Florida last year, again, these are estimated quantities as good as we can get, mining the data out of MAC, but we used 775,000 tons of wrap, which that was roughly 50,000 tons of binder coming from the wrap, and then the other 725,000 tons would be the aggregate in the wrap. Again, wrap is a great sustainable material, and the contractors in Florida do a great job of recycling, the old roadways back into our system. Just historic and current wrap usage. We kind of have two categories. I'm kind of excited. Next year, we're going to have to create a third category. We'll talk about that later. But again, for unmodified mixtures where there's no limit on wrap usage, on average, contractors average 24% wrap being used. And the maximum this past year was we had a mix design that used 50% wrap. When wrap is restricted because it's a polymer modified mix that allows the use of wrap, when it's restricted to 20%, the average usage was 18%, and obviously the maximum is 20%. Pretty consistent there. Mix cost data, more the same. The average cost of mix so far this year is not much different than last year. Still at all-time highs of around $109 a ton, but not a big increase over last year. Binder cost, those have gone down. Obviously, this has been a weird year that I hope we don't have a repeat of. But with COVID, we've seen gas and binder prices drop. Obviously, this is based on the index. We had a little freeze there on the index for a few months, but you can see the prices have come down with respect to the index, both for the unmodified binder and the modified binders there. Again, I want to go ahead and give the 2021 high polymer binder forecast. I'm going to take my time on this slide, so you guys that really want this information can get your Snagit tool or your camera out, take a picture of the slide. It's a little different this year. We've pushed some projects just a little bit. So the 3 projects highlighted in yellow, I actually showed last year as forecasted for 2020. Those let dates have moved. So you can see total high polymer binder forecast for next year is 167,000 tons, but a little over 60,000, actually almost 70,000 tons of that, well, more than 70,000 tons of that is actually a holdover from the previous year where the let date shifted. For the 2 projects up top there in Duval and Osceola County, the let date only shifted by a month from December to January. The big project there in Marion County, that's got a lot of high polymer on it, that one shifted, I think, from October or November into May of 2021. There's a lot of high binder on that project. I'm going to talk just briefly. That's US 301 in between Ocala and the split with 441. And when you think about that corridor, that's kind of the shortcut coming up I-75 to Jacksonville and 95 north. That gets a lot of truck traffic. And that project's got some running, but a lot of fatigue cracking, and that's why we're using the high polymer there. Is we're going to take advantage of the benefits that Buzz talked about earlier. We've got that full depth alligator cracking. We're going to get it all milled out and put it back high polymer to assure it doesn't come back again. So a lot of quality of high polymer binder, but again, it's really going to help with the constructability of that project. So some pay factor data. Again, you guys see dollar signs and we see quality. So it's a win-win. So this past fiscal year, the average pay factor statewide for all mix types was 1.018. That's a 1.8% average bonus. It's up a little bit from the previous year, but in line over the past several years. You guys usually average somewhere between a 1% and 2% bonus. So outstanding job. That means really good quality mix for the state of Florida. Just a breakdown by the different pay factors. Again, this is for dense graded pay factors only now. And you know, again, you can see 1.018 overall, not only for both mix types, but for the dense graded mixes as well on the CPF. Nice to see the density pay factor went up just a little bit. It's now at full pay. Good job, guys. I like to see that. You guys know I'm a big believer in density. And again, most of the other pay factors ticked up a little bit too from last year. Open graded pay factor data, again, it was just a touch over 1.018. It was at 1.019 average for all the FC5 mixtures. And again, the smatherings there, you know, roughly about a 2% bonus on each pay factor, a little less for the 8 sieve. You guys never care about the 8 sieve much anyway. No, good job overall, good quality on the FC5 mixtures. As we always do, we'll recognize the top 3 producers with respect to composite pay factor. We'll do 2 separate groups. We'll do the larger producing contractors that do over 100,000 tons first. So, and it was really tight this year. So I had to go to 4 decimal places to differentiate. So in 3rd place, Howie Engineering, as you see, I had to go to 4 decimal places, 1.0267. Outstanding, Howie, good job. Just above them was General Asphalt, a good rivalry down there, I guess, in Southeast Florida. And you see, had I only gone to 3 significant digits or past the decimal place, it would have been a tie. So we had to carry it to 4 places. Really good quality going on down there. And number 1 overall this year, continuing with the theme, preferred materials. I think they won everything today. So a 1.0361, really good quality there, preferred. And again, just you know, we see quality, you guys see dollars. That's good. For the small producers, again, a minimum of 25,000 tons up to 100,000 tons produced. Again, it was really tight. In 3rd place, the Asphalt group at a 1.0385. Just above them in 2nd place was PV and Son. Again, if I hadn't gone to the 4th decimal place, it would have been a tie with the rules of rounding. So PV and Son, nice job. And then in 1st place for the smaller producers was Group 3 at over a 4% bonus. So really nice work there, guys. Outstanding. Moving along, I'm going to talk just a little bit about quality control that adds value. This sign is not new. You guys have seen it for years. Quality control always costs less than remove and replace. But I want to talk about some very small investments and wise use of equipment that I think can really improve your risk and improve the quality of our pavements. So again, we're going to talk briefly about slippage and end-of-load segregation, 2 things nobody wants to see. But first, let's talk about bond strength testing. Now, there are some contractors out there that have already purchased this equipment. It's not expensive. Most contractors already have a Marshall test press. That's all you need. You know, you don't need a fancy loading head or anything like that. A Marshall test press will work for this test. And every contractor is already cutting cores on their projects. So you've already got 2 of the 3 done. All you need to do is buy one of these interlayer bond strength testers and then get the shims. And the shims, once you learn how to cut the cores, they're optional too, because you don't need the shims if you cut the cores the right way. So again, one of those off the counter is less than $5,000, I believe, last time I bought one, or I bought one for the state. So not a lot of money, and you're already doing everything else and have everything else you need to do this test. And you've already got a guy in the lab anyway. So again, the idea is, look, you would use those test results for your informational purposes. You know, while we've used the bond strength test for forensic evaluations and to address issues when there's bond questions where there's been spec violations, I mean, the idea is you would have the equipment, you would use it as you see best fit. It's not going to hurt you. But what it will do is help you assess the effectiveness of your paving operations and also minimize potential warranty issues. Back when I was in the district, probably one of the top 2 warranty issues I saw was slippage. It wasn't widespread, but you know, again, it happens after the project's final acceptance, and mobilizing one time to fix slippage will pay for the equipment you need to run the test. So again, you don't have to add this, it's optional, but it's a great tool to help assess your level of quality and minimize those warranty issues. If you're interested, you're more than welcome to call, myself or Greg or Wayne and talk more about the test. The test method that governs the test procedure is listed there. There's the link to it if you're interested. It's on our website. Again, it's effective quality control you can do that's only going to benefit you and your operations. The other one I want to talk about is even more simple because you've already got all the equipment you need. And again, thankfully this year I haven't heard a lot about end-of-load segregation. I'm knocking on my wooden desk. I'm hoping I'm not about to jinx us, but the weather's getting cold again. That's when segregation usually crops up. The problem with segregation is you can't always see it while you're paving. You can see what causes it. If you see the hopper running empty or, you're excessively folding the wings, you're stopping a lot, yeah, there's your causes. Why you can't see it until after you've rolled it a lot of times with that thermal infrared gun, if you're effectively monitoring the temperature of the mat when the mix is at the truck transitions, you'll see differentials, and you should investigate those. And if you investigate them timely, you can make adjustments before segregation gets out of hand on your project. When you see that difference across the mat and the temperature, at the truck exchanges, mark where it's at, evaluate it, use your nuke gauge. You've already got one of those on the project too. Use that and see, hey, is the density jumping around? Do I have a problem? Cut a core or two. But again, nobody likes to see a day's worth of segregation, and the good news is you don't have to. So use the equipment that's out there, guys. It's effective and it works. Shifting gears, we'll talk some more about pavement performance. Mark and Stacy both covered that. I ought to give you a quiz on this as well. Again, like Stacy said, we've got a statutory requirement to ensure 80% of our system meets department standards, is not deficient. We've had some other internal goals. That was a good question that Mark asked. We've had different internal goals over the years. Right now, this is our requirement. You can see this after this past year's survey, we've got a deficiency percentage of only 12.5% overall. And as usual, the predominant distress is cracking. Now, keep in mind that cracking rating includes both cracking and raveling. Those are the two that are visually assessed. At some point in the future, those will be automatically assessed just like rut and ride are. But for now, those are still visual assessments, and they are our predominant distress. We've got very good smooth roads with only 1.3% of our system being considered deficient with respect to smoothness, and very happy only 0.3% of our system's deficient with respect to rutting. Again, rutting is a safety hazard. Ride gets the driving public upset. So when your distress is primarily cracking, and again, most of ours is either raveling or top-down cracking, that's where you want to be. That's easy to fix, and it doesn't cause a safety hazard for the most part. Again, breaking it down by our three categories, you can see we've got a pie chart. I try not to get too complicated with my charts here, but 87.5% of our systems considered sufficient. And again, the little small red piece of cheese there, that's the deficient part. With respect to the interstates, they're in even better shape than overall. Only 8% of the interstates are deficient. The arterials are at about 14%, and then the turnpike is at 7.5%. Again, do a good job over there. You're paying for that little extra for that road, so it's in good shape. Historical statewide performance, again, just showing where we were and where we're at now. Again, the blue line on this plot is cracking. The red line is the ride, and then the yellow line is the rutting. And again, not much change from last year. That's good. Here is the most complicated chart I show today. Again, you've got the overall deficiency is this blue line that grows across. The red line is where we don't want to be, where we're statutorily deficient, being over 20%. But these little light blue bars show the number of lane miles that were resurfaced over the past year. And the takeaway is, look, we're doing less resurfacing, and yet we're still maintaining a system. And again, that's a credit to everybody, but especially the contractors. You're giving us a good product, and that's critical. That allows us to do more capacity, and still provide a very good system. And again, I went out west not too long ago. I drove through a lot of states, and not one came close to the quality of our roads in Florida. So we're doing an outstanding job. We'll go through each district just to show where they're at. District 1, not much change from last year, doing really well. District 2 doing a little bit better than last year. They've had an uptick in cracking, but they've got that under control and are trending in the right direction. District 3 is a little high there too, but doing all right. District 4 is in really good shape, doing really well. Again, more of an urban district. The ride's a little higher, but that makes sense when you've got more of an urban environment. District 5, very similar to some of the other more rural districts, you know, a little higher in cracking, but really good on rut and ride. District 6 is kind of the oddball because it's very urbanized down there. And so it's the only district where we've got more roadways deficient with respect to ride than to cracking or rutting. But again, both low. And again, it's just the nature of the how urban that district is. And then District 7, looking more like some of the other districts there. And then the Turnpike is really got it going in the right direction. They were a little high last year, but they've turned it around really well and are trending in the right direction. Okay, shifting gears, and I'm going to do some spec updates. What I'm looking for most in our updates is a better colored book. We've got this garnet and gold book for January 2021. Hopefully we'll see an orange and blue book again for the next one. But anyway, we'll go through spec updates for the last couple of cycles and then also briefly highlight the specs that are currently out for industry review that are proposed for the July 2021 book. So in the July 2020 workbook, the big change with respect to asphalt, I won't hit the minor ones, was the increased allowable maximum lift thickness for the type SP 12.5 structural course mixes. I think that's a really big benefit. We've talked about it before, allowing up to a 3-inch lift. Again, you give us density, smoothness, texture, and cross slope, and 3 inches in one pull. That's great. So, you know, it really allows for faster construction. A lot of our system, a lot of times you're doing on the interstates or rural highways, you're doing a 3-inch SP layer, and then with FC5 on top, this allows you to do that in one pass. That was the only major change for July of 2020. For the January 2021 workbook, the stuff that goes in place next month for everything that's let after January 1. So the first big change in the base spec is type SP 19 millimeter mixes will be allowed for use as base. That's new. There was a lot of compelling arguments for that. You know, we've got a little bit of a safeguard in there since it is a new item. We'll talk about that, but I'm excited to have that versatility for contractors that want to use that. We've also got new allowable layer thicknesses for base courses. Again, a lot of I think it's, again, don't quote me, I think it's optional base group 9 or 10-1 is 6.5 inches. And so normally you've got to do that in 3 lifts of base. Well, this change in layer thickness allowing you to do a 12.5 lift or a B12.5 lift up to 3.5 inches thick allows you to pave that optional base group in 2 lifts now. So again, the maximum thickness is raised up to 3.5 inches. And then obviously we got to have new allowable layer thicknesses for type SP19 since that's a new base type, and it's the same as the regular spec, 2 to 4 inches. Again, we're opening up, giving the contractor more flexibility, but we need to safeguard the department too, make sure we're getting good performance from our base courses. So if you're going to place more than 3 inches as the first lift of base over subgrade, we're going to require density testing. Again, we give you 3 inches on the subgrade with no density testing. If you want to go thicker on the first lift, we need density testing to make sure we're getting the same quality we always have. Again, but if it's a 6.5 lift total base, you do 3 inches on the first lift, 3.5 on the second, we're good. No additional requirements there. And then again, the concern with the 19 millimeter base is the possibility of permeability. So if you're doing 19 millimeter base mix, then we're going to require density testing regardless. And again, the big concern is, I think some contractors wanted the ability, a lot of the, I hate to say this, concrete asphalt base underneath concrete is 4 inches thick. Contractor wants the ability to do that in one pass with the 19 millimeter base, go for it. Obviously, give us density, and obviously met all the other requirements for base underneath concrete, and yeah, it allows for a little bit more of a optimization of that process. So updates to January 21 workbook for 334. We updated some of the requirements for continuous wrap stockpiles, just being a little more clear what's expected, worked with the industry on that to get that in. The big one, or one of the big ones, is the increased allowable wrap usage up to 30% for structural courses containing the 7622 binder. Again, we're going to characterize the wrap on the percent passing the 16 sieve and the high PG grade to see if that's allowable or not. And I'm going to talk more about that during the research section. But again, that's a new change. Updated requirements for instances where the gyratory pills are damaged, and so maybe you only have one or they don't compare. We've put some language in there to address that. It's kind of a hole in the system. Also updated some language for binder and mix recovery sampling and testing in this edition of the workbook. And then the proposed changes for the July 2021 workbook. These are not approved yet. They're out for industry review, I think, still. So that process is still ongoing. Again, we worked with the industry on the revised density requirements for unsignalized side streets. Again, I think it was a good collaboration, compromised a little bit, but again, listen to some of your concerns and I think address them in a fair manner that protects ours and your interest. Along with that, though, we revised the spec limits for density testing. Again, these revisions in no way hurt the contractor. They're allowed to give you more flexibility to give us really good density without the potential of getting penalized for too good density. So we bumped up the upper spec limit and for normal production, and then also did some significant revisions to the density ranges on the small quantity pay table. It's kind of hard to show in a presentation, but again, it's just to give the contractor the ability to give us really good density without the potential of being penalized. So really excited about that. I'm hoping to see the average density go up a little bit. Some changes for asphalt concrete friction courses. Again, I'm going to talk about this a little bit more in the research section after Jamie gets done with his part. But again, we're constantly looking at how do we improve the performance of open graded friction courses, the FC5 mixtures. They don't last as long as the dense graded friction courses. It's about a 4 to 5 year lifespan difference. And so one of the areas that we've looked at is do we need more anti-strip, specifically in the granite mixtures. Granite and asphalt don't play nicely all the time when there's water present, and obviously FC5 water's flowing through it every time it rains. So really good study done by NCAT showed potential for increasing or requiring liquid anti-strip, and then also increasing the amount of required hydrated lime for the Nova Scotia granite mixes. So that spec change is out there. I'll talk more about that in about 20 or 25 minutes though. So just know that's out there. And that's all I have for now. Are there any questions?
Thanks, Howie. That was fantastic. We did have one question come in, and can you briefly describe the process for deciding when high polymer, or HIMA as Dr. Powell called it, when that is going to be specified to be inside the mix?
Great question. And Buzz was right. We have not at this point increased the layer coefficient. He asked me to verify that. That's correct. We look at each one of these projects specifically. So the district evaluates it first, and then their materials office will get with me and recommend the use of high polymer on a project. Everyone will come to my office, and usually it's me looking at it, or Greg or Wayne if I'm not around. But we're looking, does the engineering make sense? Is there the potential, or is there significant rutting on the project, or is there significant cracking, especially full depth type cracking? The idea is it's a premium product. We want to do it when the engineering makes sense. So again, where you're seeing the high polymer used should be those two locations. The third alternative now is based on recent research that was completed, is areas where we've got raveling FC5, significant raveling FC5, especially like more of an urbanized or suburban area. The high polymers has been shown to have more durability. An example is the recent project that was done down on State Road 200 in Ocala at I-75. I mean, that was just a nightmare, the old FC5 out there. Maintenance was out there, patches everywhere. That job had high polymer in the FC5. Again, we think we're going to get a lot better performance with respect to raveling there. So those are kind of the three criteria. You've got significant rutting, or really, full depth, significant cracking, or if it's raveling in the FC5 is where we're looking to use it. And you can see the numbers. It's about 5% or less of our system right now. It's a premium material that needs to be used wisely.
Thanks. That's well said. Can you give an update on the department's thinking on using RAP and lime rock friction courses?
Yeah, that's a study we wanted to undertake. We're still going to consider that and look at that. We've had a little bit of problem with the equipment. So I talked about that last year at the construction conference, and we had just received the equipment then. Unfortunately, there's just we're still working through a lot of the slabs are cracked, and so we're still troubleshooting that. So we're still looking at that as an option, but we're probably 9 or 10 months behind schedule, and it's a little unfortunate, but it's just we need to get that little defect fixed, and we're working closely with the supplier and a couple other entities that have that equipment. There's not a lot of those slab compactors out there, but we're hoping to get back on track. We have not forgotten that study, and as soon as we get the equipment issue worked out, we're going to resume that and get that going again.
Fantastic. We look forward to that. And then finally, do you expect there to be a DCE memo to allow for the base course spec changes to allow them for current projects underway?
Yeah, I'll talk with Rich about that. That's a good point. I hadn't actually thought of that, but there's definitely something we can do. And just with that question, we're not going to do it for the increased RAP in the structural courses yet, because there would be such an influx we probably couldn't keep up. That will probably come though in the future, but we need to kind of deal with the ones that it lets on. But yeah, the base courses, I'll work with Rich and we can discuss that and see if we can move forward there.
Well, fantastic. And Howie, the way this is going to work, we're going to bring in Jamie Greene presently to discuss research, and then Howie's actually going to pop back on and give us a materials office update as well. So we'll see you again probably 15, 20 minutes or so. And thanks for sharing your wisdom with us.
Okay, thanks a lot. See you in a few.
Absolutely. So up next is Jamie Greene. Jamie's been with the department for almost 12 years. He currently manages the department's accelerated pavement testing program, but has also led the statewide network and project level pavement condition survey programs. Jamie has a bachelor and master's degree from Auburn University. So I think today we were all Auburn and UF. Jamie, thanks for joining us, and the virtual floor is yours.
Hey, Mark, can you see me now?
I can see you and I can hear you.
All right, can you see my screen?
Yes, I can.
Okay. Well, I'll go ahead and get started, and I'll probably just turn off the camera right now so people can see the full screen, and then I'll turn it back on later. But so primarily what I want to talk about today is just kind of give you a quick overview of some of the accelerating pavement testing research that the department is planning and currently performing. So I do have a quick outline here. It's just very, very short. I'm just going to talk a little bit about our program overview, and then talk a little bit about some current and planned HVS experiments. HVS is Heavy Vehicle Simulator. That's what we use for our accelerated pavement testing. And then I had one contracted research effort I wanted to talk about, and it's automated identification of raveling. So it's something kind of Howie mentioned that just very briefly in his presentation. I'll talk a little bit about some research we're planning there. So I think a lot of people here have already heard a little bit about accelerated pavement testing. You know, the track at NCAT is an APT facility, accelerated pavement testing facility. You know, the facility we have here at the State Materials Office is also an APT facility, but you might not realize there are about 14 active APT facilities in the US and even more worldwide. I think it's become a very economical means of assessing pavement materials, designs, and construction methods. You know, a lot of us are familiar with the ASHO road test performed in the 1950s. That was an accelerated pavement test again. And APT, of course, the ASHO road test in particular has been very instrumental in advancing pavement performance and design knowledge. So this is just a photograph of our APT facility here in the State Materials Office. It was initiated in 2000. For about 17 years, we had one heavy vehicle simulator, and in 2017, we purchased a second one. So if you look at that photo, you can kind of see the top of the HVS's, in that photo there. One's on lane 1 and one's on lane 3. So we have 7 asphalt lanes that we use as part of our HVS program. 5 of those lanes are 450 feet long, 2 are 150 feet. Then we have 2 test pits where we can raise the water table and do research on different things like that might include different base types and different water depths. And then we have a test strip that we use during construction to kind of dial in rolling patterns and things like that. So when we do an HVS test or an APT test, typically we're focused on a rutting comparison or a cracking study. And we do both of those differently with our HVS. For the HVS rutting protocol, we raise the temperature of the pavement. So we have a heater system inside that environmental chamber. You kind of see those white panels. We kind of enclose the whole HVS undercarriage and heat it up to 50 degrees Celsius. Then we use a super single tire loaded to 9 kips, and we use a 4-inch wheel wander. So we actually apply about 10,000 passes of that wheel every day, and we accelerate the damage by using a super single tire and then reducing the wheel wander to just 4 inches. So if you look on the right there, there's the HVS Mark IV. That's what we purchased in 2000. That's the original HVS, and then you can kind of see the super single tire in that lower picture. And then if you look real close, you can see a laser profiler on either side of that tire, and that's what we use to measure the rut depth for our rutting studies. And so typically we terminate the test when we achieve a 1/2 inch of rut, or we've had at least 100,000 passes from the HVS. So when we're looking at the different cracking studies, we have to do a little bit more work. In this case, we typically precondition the pavement. One of the things, maybe one drawbacks of APT is that we typically try to perform these tests very quickly in terms of when you're kind of in relative to what we might do in the field. So we typically pave, and then within 2 or 3 years we're done with all of our HVS testing. But to really get cracking in the field, there's a lot of aging that goes on. Typically we see cracks initiate on our field sections, on an actual roadway, after 5 to 7 years. That's when we start seeing cracks initiate, and that's due to the aging and the oxidation of the binder. So we've developed a method here to kind of precondition the pavement, and we call it an accelerated pavement aging system. I'll talk about that in the next slide, just a little bit more details. But we basically, for 40 days, we precondition the pavement. So we basically heat it up to 95 degrees Celsius, and then we actually just do the testing at an ambient pavement temperature, but we are looking at a cooling system to add to the HVS. So that might also be used to accelerate cracking of the pavement then if we were to implement that. So in this case, for cracking, we use a dual tire with 4 inches of wheel wander. And we start with a load of 13.5 kips, and we slowly increase that load. And generally, to initiate a crack on our test track, it takes several 100,000 passes. So, that's kind of the challenge we've had with our HVS in the past. Cracking is not as easy to get as rutting, and a lot of that has to do with how stiff our lime rock base is in Florida. Generally we have a kind of thinner asphalt pavements compared to other states, because that's primarily due to the very stiff lime rock base that we generally use. Another thing with cracking is that instrumentation is very critical. We usually put strain gauges within our asphalt sections there, and then we can monitor the strain of the asphalt as we're testing it. And then we can also use a camera system to monitor the cracking. So once cracking is initiated, we can capture the cracks with this camera system and kind of map the cracks as they progress. So this is our accelerated pavement aging system. It is basically a big box. It's 10 foot wide by 24 foot long, and it's got 12 heaters. And again, I think I mentioned this earlier, but we heat the pavement up to 95 degrees Celsius. And if you follow some protocols established in some former NCHRP studies, we've developed a methodology to kind of relate this accelerated aging to what we might get in the real world. And that's where we come up with that 40 days. That gives you roughly about 5 to 7 years of aging in a real world scenario. So I'm going to talk about some of the current HVS experiments that we have planned. This is a HVS 10. This is our 10th round of HVS experiments. So we have 5 experiments planned, or 5 studies planned. We just milled and paved the tracks in 2020, or June 2020. So we don't have a lot of data to show yet, but I'm going to go over each of the experiments and what we're planning to get out of these experiments. So just another note, we're awaiting material to complete 2 of the studies, and I'll mention that as we get to those. So the very first experiment I want to talk about is a comparison of a 9.5 millimeter versus a 12.5 millimeter mix. I think most people here are aware that there's some limitations on when and where you can use a 9.5 millimeter mix. So it's limited to the top 2 structural layers and 2 layers max. And then we can't use a 9.5 millimeter mix in traffic level D and E applications. So I guess we feel like these restrictions may place some unnecessary design and construction limitations. So the real objective here is just to compare the performance of an SP 12.5 and an SP 9.5 mix, both in terms of rutting and cracking. And if, those performances are comparable, then there will likely be some changes to that 334 spec. Another thing that we're looking at is a scabbing study. So, I think everyone is familiar. If you don't, you're probably familiar with what scabbing is, but basically this occurs when you fail to remove the entire existing lift when you're milling. So what we did to try to simulate this is we did some variable milling on one of our test sections. We were trying to leave some scabs, and you can see a picture of one that we had managed to leave behind there. So what we did then is when we placed the overlay, we also kind of did some static and vibratory compaction as well. So in addition to the scabs, we had some sections with a vibratory compaction and some sections with just static compaction. And what we're trying to do is look at how that affects the bond condition of the asphalt pavement. And so we also want to look at, how the bond is impacted and then how that affects performance. So what we did after this is after we milled the surface and we left some scabs behind, we went and mapped out where all those scabs were. When we put an overlay on top of that, then we came back and cut lots of cores where we knew there was some scabbing and where we knew there wasn't some scab, so we could evaluate that bond condition. Another thing we're looking at is a thick lift study. So of course, when sections with full depth cracking, they require a deep mill and fill. So this would give us a kind of a tool to accelerate rehabilitation. So in this case, you can see there on the right, we're milling down 6 inches, and we placed 2 different sections. One 6-inch single lift with our standard polymer modified asphalt, and then another 6-inch lift with a warm mix asphalt. And so what we want to do here is evaluate both the constructability and also the performance. So one of the things that we did just to kind of evaluate the constructability is we've measured the cooling rate. So during construction, we placed thermocouples within the asphalt layer. And you can see there on that image there, we placed the thermocouples at 1 inch below the surface, kind of in the middle of that 6-inch lift, and then at the bottom of the 6-inch lift. And what we found was that it took about 5 hours to cool down to 160 degrees Fahrenheit, and maybe a little bit less near the surface. So that's some important information that we'll need to keep in mind when we start to use this in the real world there. This is one of this, this is a section, or this experiment is actually something we've been focusing on really. That's where most of our time has been spent in these first few months. So we hope to be able to get some information out soon and potentially get this implemented fairly quickly then. Another experiment we're looking at is the comparison of an Elvaloy binder with our standard, or kind of our gold standard PG76 -22 polymer modified asphalt with SBS modifier. So this is really just a kind of an alternative binder modifier that we want to look at. Binder production cost fluctuates, and we're always looking for better performing binders and mixes. So this is something we want to look at in this round of HVS experiments. And just the photograph on the right is we're installing some strain gauges in one of these test sections here. And I mentioned earlier, for our cracking studies, the measurement of strain is very important. So that's what we're doing there in this photo. This is a section here that we ended up having to mill up. Once both the department and the contractor weren't quite satisfied with the Elvaloy binder results, so we've milled that up, and we're waiting for delivery of some more mix with the Elvaloy binder. And then the last HVS study I wanted to talk about is the low gyration study. So asphalt mixtures with lower design gyrations typically yield higher binder content, and that potentially improves durability and performance, but there might be some trade-off, as most people probably know, with rutting performance. So that's the main objective of this experiment, is to compare the performance of mixtures with a design gyration of 100 and design gyration of 50. So again, this is during construction, we found some problems with the volumetrics in one of the lanes there with the lower gyration. So, both us and the contractor agreed that that particular lane needed to come up. So we're going to be replacing this particular lane when the Elvaloy binder is back in play, and we're paving both of those lanes. So those are kind of all of the HVS studies that we're going to be working on this year, or probably over the next 2-year period. And the next slide, and this is really my last slide here, but I wanted to bring this up. This is a contracted research effort, and the point of this research is to try to develop a method to automate raveling detection. I think Howie mentioned earlier when he was talking about our pavement condition survey that our cracking survey includes both cracking and raveling, and that's right now that's the only visual assessment that we use for our pavement condition survey. Everything else is automated. So the State Materials Office has procured this new 3D pavement data collection system that's shown on the right. And really the main difference here is that antenna, or the laser system that you see hanging off the back of the van. Now, the front of the van is kind of our standard 3-laser profiler that everyone's familiar with. That's what we use for acceptance testing, and we also measure rutting and ride in our annual condition survey with that front bumper. But that back laser is basically the new system. And you can see at the bottom photo, or the bottom image, you're basically capturing 4,000 height laser measurements across the lane width. So that's about a millimeter resolution transversely across the lane. And we can also measure about a millimeter resolution in the longitudinal direction too. So when you kind of put this matrix together of height laser measurements, we can automate cracking. And then this research project is focused on how can we automate raveling detection. That's something that is not quite as mature yet as the cracking detection that people are working on. So one of the things I wanted to bring up then is this is something that, once we have this working and we have more of these systems in play, and we're doing our entire pavement condition survey with this, I believe we're going to be able to identify sections that pose a raveling problem earlier in the cycle. And I think we'll be able to identify those and then potentially have more FC5 only overlays in the future. So we'll be trying to identify these sections that might have a problem with raveling much earlier. And instead of waiting until maybe 12 to 14 years where you have raveling and cracking, we can identify them when we know that there's only raveling and no cracking involved. Then we'll be able to just mill off the FC5 only and replace that. So that wraps up my presentation, Mark. If there are any questions, I'm welcome to, I'm happy to answer any questions that there might be.
Yeah, we have one. Can you describe so the department does a lot of very impressive research. What's the process to decide which projects are researched?
Yeah, so we have a process that we go through every year. Actually, it's what we do is we generate the kind of research ideas from our districts, and we also try to reach out to industry too. I think I might have reached out to you earlier in the year, Mark, and if not, since you're new at this, you're new in that position, you're welcome to contact me or Howie or any of us, if you have some research ideas. But generally every fall we try to generate these research projects, and then as a group we kind of rate them and we figure out which ones are best addressed by APT, accelerated pavement testing, and then what research projects are best addressed by maybe contracted research efforts, and then what projects are best maybe just like a demonstration type project where we might look at districts and figure out, hey, maybe this is a material or a product that doesn't necessarily need to be researched, but we need to demonstrate, in a real field project how that was working. So we kind of look at all three of those things as methods to implement research. So that's so basically generally, for the HVS and all of our research, I think the research projects kind of generate from the district initially. And so that's that's where we really focus on trying to answer problems that they have. But if there are problems that are generated from industry as well, we try to address those too through that process.
Well, it's a very impressive research program, and Florida's all the better for it. So thank you for spending time with us today, Jamie. We greatly appreciate it.
Thank you.
And up next is once again the great Howie Moseley. Howie, do we got you still?
Yeah, I'm still here. Can you hear me?
I can hear you.
Awesome. Let me get my screen ready. So sorry guys, a double dose of Howie. It is your unlucky day. So anyway, I'll turn my camera off and we'll go ahead and jump into this. All right, so just a little to kind of complement some of the research Jamie has shared, just some different research projects we've kind of got going out of my shop. Presentation outline, this is less scattered, so I have an outline this time. We're going to talk just briefly about the project that allowed us to allow more wrap usage in the structural mixes with 7622 binder. In case you weren't at the construction conference, I'm going to briefly highlight that project. Going to talk about the recent research that was completed by NCAT that'll really kind of help us make the spec change with respect to the additional anti-strip additives in the granite FC5 mixtures. Briefly talk about the State Road 200 air mid-fiber test sections that we're hoping to place either late this month or next month, and then some just quickly spotlight some ongoing and upcoming research projects. We hadn't had a chance to talk in a while as a big group, so there's some new stuff just to give you updates on what's going on. So we'll go fast. I know you guys want to be done by 4 o'clock. So The project with UF is the one where we looked at the enhanced characterization of wrap for cracking performance. Again, this is the objectives were, look, can we use more than 20% wrap in the PMA mixtures without hurting performance? And then how do we characterize that wrap to do it effectively? So again, it looked at wrap sources from across the state, and they did a lot of high-tech testing, stuff we can't even do in our lab in some cases. And the goal was do the high-tech testing and then make it simple. And UF, they hit a home run with that. So they did interstitial component direct tension testing. I can barely say it. I certainly can't tell you what it really is other than pulling apart asphalt in a dog bone shape. They also did some super pave IDT testing to verify those results. And they came out with some very simple characteristics. Percent passing the 16 sieve on the gradation of the wrap, and then the high PG grade of the recovered binder from the wrap. Stuff we can do. So the testing showed coarse wrap performed better than fine wrap. That also the stiffness of the wrap binder affected performance, but it wasn't quite as important as the gradation, surprisingly. So in general, a coarse wrap with stiff binder would have better cracking resistance compared to a finer wrap with less stiff binder. Again, that's all relative, but it just emphasizes gradation of the wrap is important. We'll talk about why in a minute. Obviously, a coarse wrap with binder that's not too stiff would be the best. All right, why is the gradation so important? So some of the wrap binder is going to stay on the wrap aggregate. And then the finer portion of the wrap becomes part of the mortar in between the coarse aggregate skeleton and the mix. And that's what affects the mixture's cracking resistance. And again, that's my very simple, in my mind, how I understand it. It's a lot more complicated than that. But basically, you want the stuff holding the coarse aggregate together to have less wrap binder in it. And that's going to lead to better cracking performance. So the project conclusions, you can characterize wrap fineness and wrap binder stiffness, and that's required to increase the current wrap content in mixtures containing 7622 binder. So we can summarize that in the table that's out in the new spec. This is table 334-3 in the January 2021 spec. And then look, every once in a while we get really complicated here. This is a really complicated table. The first thing you want to do is you want to look at your wrap gradation on the 16 sieve. So you're kind of looking at this row here, and you'll characterize your wrap. If it's a coarse wrap, less than 40% passing, then you're going to look down this column. If it's an intermediate wrap gradation between 40 and 50% passing the 16 sieve, you'll look down this column. And then if your wrap gradation is fine, more than 50% passing the 16 sieve, then you can't increase your wrap percentage. You stay at 20 or less. So determine your column you're in, and then you look at your high PG grade of your recovered binder. And again, if it's less than 100, a PG 100, then you can go all the way up to 30 if you've got coarse wrap, and you can go up to 25 if you've got the intermediate wrap gradation. If you've got questions, call Greg, Wayne, or myself. We'll talk you through it. Again, the way it'll work is you'll submit a sample of wrap to our office. We'll characterize it for you with respect to the high PG grade, and then it'll tell you how much wrap you can use in your mix designs. Anyway, I'm excited about that spec change and looking forward to getting it implemented. Next project was the increased anti-strip additives in the granite FC5 mixtures. This was research done by NCAT. Buzz, Randy, all the guys up there do an awesome job. The project objective was to evaluate the influence of anti-strip additives on the durability and moisture susceptibility of the granite-based FC5 mixtures. Again, if you want to read it in detail, there's the title of the project. You can Google search it, it'll show up somewhere. The project variables, we looked at both Georgia granite and Nova Scotia granite, and then we had kind of 4 different dosages that we looked at with respect to anti-strips. So the current standard for Georgia, for granite FC5s is 1% hydrated lime. That was kind of the control. Then we added the liquid anti-strip. We also looked at just increasing the hydrated lime and not adding the anti-strip. And then NCAT finally looked at the kind of the most extreme with more lime and liquid anti-strip. Again, the testing, they conditioned the specimens using the asphalt pavement weathering system, which simulates long-term exposure to water infiltration, vapor diffusion, and thermal and ultraviolet oxidation. So you got the UV lights and this weathering station with water being cycled through. Again, trying to simulate a long-term what an FC5 mix goes through. They ran 3 performance tests: Cantabro, tensile strength ratio, and then Hamburg wheel tracking. And so the conclusions were for the Georgia granite mixtures, 1% hydrated lime, but with the liquid anti-strip had the best performance and had the best cost benefit ratio. Nova Scotia granite, more lime and liquid anti-strip was the best. And again, this is a proposed change to the July 2021 workbook to incorporate these findings into the spec. Next project, again, guys, trying to stay on track. You heard Buzz talk about aramid fibers. We have looked at these in the lab for a while now. I think it's going back as far as 2013. We've done multiple studies, but we've not really done field sections.
Hey, Howie, let me stop you real quick. Can you try to reshare your screen? I think some people aren't seeing it. I'm seeing it, but I don't know if I represent the entire group.
Yeah, I don't know how to reshare it, but hold on. There we go. All right, so I unshared it and reshared it.
All right, yeah, I think that we've got it now.
Oh yeah, there's a little audio. Okay, there you go. So guys, I apologize. I promise I didn't do anything on purpose. Mark, can you see it now?
Yeah. I think.
Okay, good.
I've seen it the whole time, so
okay.
Hopefully there's this for a few. Thank you.
All right, well, sorry about that, guys. All right, so aramid fibers, we've looked at them at a lab for a long time, but the only place we've placed them to date is on a multi-use path. You don't really learn a lot about mixture performance when the only thing going up and down the pavement is bicycles and foot traffic. So so while the performance in the lab hasn't been the best, you heard Buzz talk about that. So we're going to construct some test sections in the very near future on State Road 200 in Nassau County. If you're familiar with that area, there are 2 timber facilities at the end of that roadway. So you get an extreme amount of very heavy truck traffic on that road every day. Now, having been in District 2 where this is located, it's been one of those corridors that has always had significant distress. So we're widening the road from 4 to 6 lanes. You heard Buzz talk about perpetual pavements. We didn't get as fancy with the design, but we feel like that's a good perpetual pavement up there. We've got brand new stabilized subgrade lime rock base, and then 7 total structural inches of asphalt with the friction core speed an FC 12.5. So we feel like the distress in this study is all going to be top down. So there will be 3 test sections, each 1,500 feet long, and plus a 4th control section. And then the test sections will only be constructed in the top 1.5 inches of FC 12.5. So that's my slides here. The control sections, the standard in North Florida is an FC 12.5. It's going to be granite, obviously, 7622 binder, and since it's granite, there'll be 20% wrap. The first test section is to see, look, we're going to see can the aramid fibers perform as well as the polymer modified binder. So since that's a 20% wrap mix, our specs say use a 5822 binder. That will be test section number 1. The same job mix formula. They put the aramid fibers in, and then the 5822 binder. Test section number 2 will be the same as the control, but we'll add aramid fibers. Again, do we see even more improvement by using both polymer modified binder and aramid fibers? And then kind of the ultimate test section number 3 is we're going to put a section of high polymer binder in there. We'll use the same aggregates, but obviously it's high polymer and a surface mix where there's not going to be any wrap, no aramid fibers. And again, we've got a lot of little studies there. We're going to use the new razzle dazzle van that Jamie showed with the automatic crack and raveling, although the raveling is still to be worked out, but we're going to use those vans to monitor the long-term rutting, cracking, ride, and raveling on these sections. And then we'll do corresponding laboratory tests on plant-produced mix for each section as well. All right, so the first project I want to spotlight just briefly is is if you've ever looked at pavement closely, you get these little things in the picture called roadworms. And again, they pop up little humps, and they affect the ride. And you see them usually when the sun's low on the roadway.
Howie, let
Yeah.
me just interrupt you one more time real quick. I think there's like 10% who are still not seeing your screen, but I don't want you to do anything else. I just want to let them know that I posted these slides in the handout section, so you should be able to see it there if anyone else wants to follow along. And thanks for y'all's patience with this. Howie, no more interruptions. Floor is yours. Carry on.
That's all right. This is your show. I'm participating. But no, guys, I apologize for that. Mark's got the slides. So yeah, if you can't see my screen, hopefully you know what roadworms are. But again, we've contracted with ARA to look at this. The project is scheduled to be completed next spring. And again, the idea is, look, what causes roadworms and what can we do to help minimize them in the future? So we're looking forward to the recommendations from that project soon, because if you start paying attention, you'll see roadworms everywhere. Again, not a terrible catastrophic failure, but they do affect the ride and sometimes significantly. Use of epoxy modified asphalt and FC5. Like I said earlier today, we're always looking at ways to improve FC5. This is kind of an outside the box thing, but it's a new technology that's being used in other countries. It's also been used on bridge decks, but again, we wanted to take a look at it. Is it something that may suit us or not? So we've contracted out with NCAT to look at it. The project should be done next summer, but the idea is look, could we use an epoxy modified asphalt binder to improve the performance of FC5? If it does, is it even cost effective? If that's the case, how would we design it? And is it recyclable as wrap in the future? So again, we want to explore that. If there's something we can do to improve the performance of our mixes, we want to take a look at that. So more to come. Look forward to giving you guys an update in probably 6 to 9 months on that project. Performance of 9.5, 12.5, we're doing it at the HVS, but we also want to look at the cracking aspects. So TTI is looking at that for us. Again, the idea is, hey, look, if we can design the 9.5 mixes to be as good as the 12.5s with rutting, cracking, and durability, we need to open up our spec and let you guys use them. So that's the goal of that project. Estimated completion date is hopefully winter of next year. By then, we should have the HVS done, and we'll have the complete picture on that, both in the lab and in accelerated testing. Replacement of the Army layer. So again, you guys that have been in the business for a while, you remember the Army layer. Used to do a lot of it back 10, 20 years ago. It kind of died out for a number of reasons, mixed performance, the fact that it has no structural value, some of the constructability concerns, but reflective cracking is still an issue. It's our number one distress. Cracking is. Sometimes we don't have the budget to mill out all the cracking. Is there something we can do that kind of combines the best benefits of an Army layer, but also mix that would have structural value, be able to be opened up to traffic, that type stuff. So UF did an initial project and had some promising results. We're doing a continuation project that's going to start early next year to come up with practical guidelines on how to design these mixes. So more to come, but we're pretty excited about that. Would love to be able to better address reflective cracking effectively. Resilient asphalt pavements. Resiliency is kind of the new buzzword in transportation. And again, in Florida, high seawater rise, also just tropical storms drop a lot of rain. Sometimes we open up the roads even before the water's off the road. In those cases, especially in coastal areas, we have roads right now that flood with the tides, but we still run traffic on them. Is there more we can do to improve the resiliency of the road to make it more resistant to flooding? So this is a new study that UF's going to kick off early, probably next couple of months, and excited about what they've got there on that project. See if there's anything we can do. Again, as sea slowly rises a little bit every year, we're surrounded by water in Florida. It's something we need to look at. This is one actually, was an industry concern. We put FC5 in a lot of places, and maybe some places where it's safe but doesn't last as long. And we're talking about these suburban corridors, 4, 6, 8-lane roadways, multiple signalized intersections, U-point, midpoint, U-point, U-turn, turn lanes, a lot of stopping and turning movements. is there a better alternative? We know our dense graded friction courses are very durable, but they're not really good with respect to hydroplaning. Is there something in between FC5, maybe a finer open graded friction course or something else that would have better durability but not compromise safety? So that's a project that's going to advertise soon. And with that, I've said enough. I'll take any questions.
Howie, thank you so much. We did have a couple questions, and first I apologize to anyone on my delay of noticing the screen issue. It was working for me, and frankly, I was so engaged I didn't see the questions come in. But Howie, the question we have, and I'm going to send it to you in the chat, but then also read it out loud because there's some numbers in it. Have you considered raising the FC5 gradation sieve design on the number 8 sieve to 12 instead of 10, and raising the number 200 sieve to a lower range of 3 instead of 2 to add fines to the mix in order to reduce rattling?
We've not looked in detail at the 8 sieve. There was a little bit of an interest a few years ago with the gradation similar to the old FC2. And that's one of the things I think that may be considered in that new project. But we did raise the upper limit on FC5 to up to 5% dust, but we didn't want to arbitrarily raise the lower limit. We considered that, but we thought that was too significant of a change and people might need more time to adapt. There's definitely research out there that shows a little bit more fine material does help durability in FC5. You got to be careful not to close it up too much though. So good question. I'll need to go back and look at the that kind of finer gradation we considered a few years ago. It ultimately got shot down, but we did look at that a little bit. But we'll take another look at that. Good question.
Absolutely. Well, Howie, I think that this will be an exciting year for the department's research, and so we're looking forward to see what comes out of it, and the research that you've presented that is being implemented. Also seems like very positive changes for the state. So thank you for your work there, and well done.
All right, thanks a lot, Mark. Really enjoyed it.
Absolutely. And to everyone else, thank you so much for joining what would have been the 44th consecutive in-person Florida Asphalt Conference, but has now been the first consecutive digital asphalt conference, and we hope it will that streak will end here. Next year we want to be in person again, obviously, and I appreciate everyone's attendance here. We're going to post the videos and the slides on our website, floridaridesonus.org, in the very near future. And if you have any questions, please feel to reach out to myself, or again, if you're interested in that technical director role. With that, I'm going to thank you all for attending and end this webinar. Thanks, everyone.